Uh, okay. Okay, my presentation is a little bit out of the scope of viticulture, but I'm going to present part of the uh, one of the curricular units that I teach in the University of Porto. So, when we talk about rehabilitation of soils and aquifers, we should first know about the partition coefficients,
Antônio,
which
desculpa
sim.
interromper. Tem aí um alerta. Ative o Microsoft. Ok,
Okay,
obrigada.
okay, thank you. Obrigado. Sorry. Okay. So, first topic is partition coefficients. Uh, First, before we go there, we need to know a little bit of the composition of the soil. Uh, Soil, it's basically it's mixture of mineral particles, water, air, and organic matter. So it is something a little bit more complex when we have contaminations on just rivers or air, because soil is a complex mixture. Uh, when we add a contaminant in the soil, the contaminant naturally spreads among into each of the compartments: the water, the organic matter, the mineral particles, and the air. Uh, yeah, until a moment where the contamination gets stable, which means that the concentration in each compartment it's no longer changing. At that moment, we call it the state of equilibrium, where the concentration has reached limits, uh, a stable limit. And to know how to understand how the contaminant shares between each of the phases, the air, the water, the organic matter, and the mineral particles, we must know a little bit about the partition law. So, suppose that you have two immiscible solvents, A and B, and we place a contaminant solvent in solvent A. We can check here the differences in the concentrations. In the moment that we add the solvent in liquid A, the concentration goes up, and then in time, concentration of the contaminant in A starts to decrease because it's passing to the solvent B, and it reaches a point that we call the state of equilibrium, where the concentration does not change no longer, and that's what we call the state of equilibrium. In that moment, there are some weird thermodynamic laws, but basically, the chemical potential at the state of equilibrium in A and the chemical potential in B at the state of equilibrium become equal. And in that moment, that means that the concentration in A divided by the concentration in B, it's equal to a constant that we call the partition constant normally for the partition law. Um, so that means that at the state of equilibrium, if we know the concentration in one of the compartments, in one of the solvents, we know we can estimate the concentration in the other one. For example, when we talk about gases, when we want to know the partition between water and air, we use the known Henry's law, which is also a partition coefficient between the water and air. We can also estimate this from some empirical constants from tables. And we can also estimate it by the vapor pressure of a contaminant with the solubility of it in water. Um, for soil, the most important partition coefficient is the soil water partition coefficient, which is basically the concentration of the contaminant in the soil divided by the concentration in water. We have the octanol water partition coefficient, This one is a little bit weird because it's not common to find octanol in soils. But the thing is, octanol it's a solvent that is representative of the organic matter. So it's something easy to manipulate in the laboratory to do some experiments. So we commonly use the octanol water partition coefficient to estimate the partition coefficient between the organic matter and water. And the octanol water partition coefficient it's called the KOW, and it's determined always in laboratory. Um, so with CAL, we can also estimate the organic carbon partition coefficient, which is basically the concentration of a contaminant in the organic matter that's in the soil divided by the concentration of the contaminant in the liquid part of the soil. And we talk about the organic carbon partition coefficient because the organic matter is mostly composed by organic carbon. The organic carbon partition coefficient can also be estimated through the soil water partition coefficient divided by the fraction of the organic carbon in the soil. And the fraction of organic carbon in the soil, it's basically the percentage of organic matter of the percentage of organic carbon. Most important, we have bioconcentration factor, and this is when we have, for example, a lake, and we know that the soil is contaminated and the water is contaminated, and so the aquatic forms of life are also contaminated. We call that the bioconcentration factor, which is the concentration of a contaminant in the life forms, normally fishes, of the life forms in the lake divided by the concentration of contaminant in the water of the lake. So we use a lot to estimate this partition coefficient. We use some empirical formulas that were created from people that spend their time in the laboratory, taking a lot of samples and then trying to do an adjustment between the different organic phases of life forms and the octanol water partition coefficient, because the octanol water it's something that we can estimate in the laboratory, and the others are a little bit harder. So now let's talk a little bit about soil and groundwater. Soil is composed by a line of different profiles. The first layer it's composed by mostly by humus, and then we have the topsoil, which is normally rich in organic matter, and it's a zone where normally most of the nutrients get fixed in the soil for agriculture, for viticulture. Then we have the subsoil, which has less organic matter, but is still rich by the roots of plants. And then in the last horizon, we have normally bedrock or weathered rock, but it's a zone where we have likely less soil and more rocks. Groundwater, it's sometimes something a little bit difficult to imagine how groundwater flows or where is it. But basically in the soil below our feet, we have the unsaturated zone, which in that zone, unsaturated zone or vadose zone. Then we have the water table, the zone of the soil where we can find water, and the saturated zone. In the vadose zone, you can find mineral particles, water, and air. But then in the vadose zone, you cannot find no longer air, but just water, okay? Which is mean that all the pores of the soil are filled with water. while in the plateau zone, unsaturated zone, the soil is filled with water and air. So as you can see here, after the water level, we only have mineral particles, and in the pores you can find just water and no longer air. I have here a very quick video that might be useful to understand a little bit of how groundwater flows. I'm going to try to pass it, but if it does not work, okay, don't worry, I'll go on with the presentation. Don't worry, it's not 15 minutes. Okay, here it is. Sorry, just a question. Can you hear the sound of the video?
Not yet.
Now, can you hear it?
No.
Okay, no worries. No. Como? So basically, you can see how the groundwater moves. We are putting here a small die, and you can see in the lowest part where you have like a fracture aquifer, water moves through the fractures of the rock, while in the other zones, it's just moving between the pores of the soil, as you can see. And in some zones, the water movement it's much faster than rather than in other zones. So, and this is always something a little bit hard to imagine or to model or to estimate when we are talking about rehabilitation of soils and aquifers. Wait. Okay. Let me get back to the presentation. Okay. So you can see here an example of what we call aquifers, which are zones of the water where of the soil where you have water stored, and aquifers are always below the water table. And below the water table, you can only find mineral particles and water. Above the water table, you have the mineral particles, water and air and much more organic matter. So in an unconfined aquifer, we can on the top you have the water table, so it's closest to the surface, and unconfined aquifers are normally not under pressure. Then you can find the called confining beds, which are basically impermeable or zones with very low permeability for groundwater. And after those layers, you can find confined aquifers. And confined aquifers have on the top an impermeable or almost impermeable layer, and also on the bottom there's always an impermeable layer or a layer with very low permeability. But still, there is always some water movement in those zones that can take centuries or millennia to reach the surface waters or rivers. Okay, because during the winter, the rivers are mostly fed by rainfall, while in the summer, what gives water to the rivers, it's groundwater. And it's mostly in the summer, there's more movement from the groundwater, from the ground to the streams, to the rivers. Okay, let me show you also this video that shows a little bit of groundwater and how it moves. I hope that the advertisers go very fast. I can ignore, good. Okay, this is just an example of case study in the United States. So okay, basically in blue we have the zones with groundwater, and we can see that. So okay, basically everything starts. All the water that's in the ground comes from the precipitation that is infiltrated through the soil, and then is stored in aquifers, and then it goes through the soil through the aquifers. It can go through the pores of the soil or through the fractures that are uh, in the soil. Sometimes you can even find rivers that are basically disappearing in the soil because the water is infiltrating in the soil, and then the water always finds its own way and then shows up in a different spring. So okay, water always finds the easiest path in the ground, or it goes always in the place where you have less pressure. And then yes, it is during summer that there's more movement from groundwater to the rivers. And then sometimes water is coming from zones that water was not moving for a decade ago or even centuries. Okay, and that's the example. So, okay, aquifers basically can be distinguished into two groups. Confined, where they have impervious layers on the top and on the bottom, and are zones where the water is normally under pressure. And when you see, for example, those hot springs of water coming from the soil, this means that these waters come mostly from confined aquifers, where the water is under pressure, and at the same time you have a lot of heat from the earth. Well, the first layers of water that we find beneath our feet are normally the unconfined aquifers that are directly connected to the soil that's below our feet. Uh, it's very important to understand the soil texture that, that because with the soil texture we can estimate the degree of permeability or impermeability of the soil layers that are below us. Soil is composed by different types of particles classified by their size. Uh, Clay, the thinner, then silt, sand. It doesn't need to be sand from the beach, okay? Just sand are just soil particles that have a diameter between 0.75 millimeters to 2 millimeters, and then we have gravel that are the bigger particles. To estimate the percentage of each type of soil, we normally do some experiments for the determination of the soil texture, where you put the soil in different sieves. Each of the sieves has a different opening hole that allows for the thinner particles to go down. So we put the valve of the sieves uh, stirring for 15 minutes or something, and then we weight the amount of soil that was stored in each sieve, and that allows us to estimate the texture of the soil, the amount of particles that are sand, silt, or clay. And then we use this diagram to classify the soil in terms of classes. So supposing that we have a soil sample of 200 grams, where 100 grams are clay, 60 silt, and 40 are sand. So 50% of the soil is clay, 30% is silt, and 20% is sand. We use this diagram to know, and then we can classify the soil. And it is important to know the soil texture because that allows to estimate the velocity of groundwater in that layer where we are estimating the texture. It's not always and that the way that allows us to estimate the flow of a fluid through a porous medium, which means the movement of a fluid through a soil. Typically, we do the Darcy experiment, which is an experiment where we basically fill a tube with sand, and then we put water passing through that tube with the sand, which is our porous medium, sand, soil, wherever, and then we measure the difference of the pressure on the top of the tube and on the lowest part of the tube. And basically, that allows us to estimate the hydraulic conductivity, which is a way to measure the permeability of the soil layer. So we put the soil in the tube. Here the example is sand. We put water moving through, and then we measure the pressure, the difference of the water level on the top and on the bottom of the zone, and that allows us to estimate the loss of energy, which means the amount of energy that water loses when pressing from the upstream to downstream. And by knowing the length of the tube and the cross-section area of the tube, we can estimate the hydraulic conductivity, which is also a function of the water flow. And here we have the example, okay, of the, we have the example of the experiment. Okay, it's nothing very magical to see. We just have the tube with the soil, water passing through, and then we have different water levels, which means, and these water levels represent the energy of the water. And as we can see, the water is losing energy from your left to your right. As water is passing through the sand, it's losing energy. And with that, we can estimate the hydraulic conductivity, which basically allows us to measure the velocity of groundwater. Yes, we have here different values of the hydraulic conductivity. For example, in gravel, the thicker particles have a high hydraulic conductivity, which means that water can move easily through gravel. And clay, the thinner ones, we have a much lower hydraulic conductivity, meaning that water doesn't move so faster in clay soils. And why is hydraulic conductivity important? Well, that's because it allows us to estimate the speed of groundwater, and so the speed of how contaminant is transported through the soils and groundwater. When a contaminant is spilled in the groundwater, we have three known mechanisms of the transport. We have the advection, which is basically the water pushing the contaminant, like dragging it, and this is the dominant transport mechanism. Advection, okay, it's just the contaminant going with the direction of the water flow. We have also molecular diffusion, which is basically the movement of the contaminant from zones where the concentration is higher to zones where the concentration is lower, as like thermal energy. Okay, you have heat movement from a colder zone to a warmer zone, and when we talk about molecular diffusion, we have movement of zones where you have a higher concentration to a lower concentration. And we also have the dispersion, which is basically as the groundwater meets soil particles in its path, the contaminant starts to have some dispersion um, because the water has to dodge the soil particles and go around the soil particles. So let's just see a little bit of a difference of a contaminant particle in water. So suppose that you have a flask of water, you put a drop of contaminant, and then the contaminant follows mostly a straight path to go from a point to another. While when we talk about in soils, in groundwater, you have the water there, but you also have the soil particles. And when you drop the contaminant there, it has to follow a tortuous path to movement, okay? And that's why the diffusion laws are different in groundwater because the particles of contaminants or so whatever do not follow a straight path because they have to go through the soil particles around. Um, okay, but and the movement of the contaminant in groundwater follows mostly three dimensions, and when we want to model the dispersion of a contaminant in groundwater, we normally have to. It's mandatory to use uh, three-dimensional models where we use as input structure of the soil, the composition of the soil, and the velocity and direction of groundwater. And normally this is something not easy to model. Okay, but sometimes we can do some approaches by estimating that the movement just follows one direction of the x. And with that approach, we can use just simple equations to do a quick estimation of the movement of groundwater and contaminants in groundwater. So, first thing to use is to distinguish the type of contamination. Impulse contamination, for example, it's a contamination that happens just once, okay? So I could just drop 1 ton of contaminant in a single time, and that's called an impulse contamination. And then we have continuous contamination, which is like the contaminant is being continuously released in groundwater. And that is something very common to happen, for example, in waste piles of urban garbage, for example. Normally, the waste piles have on the bottom an impermeable layer to don't mix the liquids that comes from the waste with groundwater. But sometimes with the earth movement or, for example, small seismic activity, it's enough to a hole in the impermeable layer of the waste pile, and then the liquids from the waste pile are spread into groundwater, and this is an example of a continuous contamination because the effluent is continuously released into groundwater, and we use different equations when we want to estimate the transport of contaminants, and basically we need to know the mass of the contaminant that's released or the concentration, the area of the aquifer, the dispersion diffusion coefficients, the the moment when we want to measure the concentration, which is function of the concentration, distance to the contamination source, and the groundwater velocity, which has in account the hydraulic conductivity of the soil, okay? And then we have some kind of degradation constants here also to estimate the degradation of contaminants, because sometimes the contaminants are biodegradable, and as they are being spread in groundwater, at the same time they are being naturally degraded by groundwater. Okay, the unidimensional transport equation, we have the two different cases. Impulse contamination, it's basically the release of a big mass of contaminant, and then there's no, as it passes, as a contaminant is passing, it's then being decontaminated, okay, in time, while the continuous contamination, the contaminant is being continuously released, as you had like a tourniquet releasing the contaminant. So I have talked enough about a little bit of what happens of the soil properties of groundwater. And let's go now for some remediation technologies. First one is the case of impermeable and permeable reactive barriers, which are basically barriers that are built in the soil. Okay, barriers that we build inside the soil with the purpose to retain contaminated zones, protect zones that cannot be contaminated, or even to have barriers that react with the contaminants. Okay, here we have an example of a reactive barrier. We have the source of the contamination. The contaminated going from the non-saturated zone to the saturated zone, and in the saturated zone we have just water moving, okay? And then we have a barrier that is something that we excavate in the soil and fill it with a new material with the hydraulic conductivity that we choose, and we can put, for example, in that wall that we put inside the soil, we can put chemicals or that react with the contaminant that is passing through the barrier. Okay, as you see from the left to the right, you have the contamination plume, and on the right, you no longer have the contamination plume, because as the contaminant is passing through the reactive barrier, that's having a chemical or physical reaction with the barrier, the contaminant concentration decreases inside of the barrier. And let me show here a quick example of the reactive barrier. Uh, so, for example, we have a contaminant released from an industry. Okay, and the contaminant is being released in groundwater. Okay, this is not a lake. This is just showing up the structure of groundwater. Everything here is happening underground. So you are having the contaminant release, and then we go to the site and excavate a wall to build inside the soil. Okay, here the white parts are impermeable, meaning that water doesn't pass there. And now this structure with three layers, where the darker ones are just allow water to move. In the red area here, you have the zone where you fill it with something that reacts with the contaminants, okay? And then you fill the soil with these three layers, and then groundwater is forced to pass through the reactive barrier, and then the contamination naturally decreases. Of course, that when we have a barrier like this, it doesn't last like forever, and sometimes it's needed to replace the wall, the filling, the material that's filling the barrier. Okay, and this sometimes needs to be replaced. Sorry. And normally we use mostly zero valent iron, okay, which is basically iron without ionic charge. And zero valent iron is very good for the absorption of halogenated contaminants. Okay, but that's just a technical detail. But other materials can be used. Okay, zero valent iron was very commonly used, but now new studies have been finding new materials to use. For example, um, a mixture of iron with sulfur. Okay, but then we have a plethora of materials that you can use to fill the barriers with, but most commonly it's zero valent iron, also by because it's not a very expensive material. Okay, non-reactive barriers are not something so magical. It's basically a barrier that you put inside the soil just to change the water level from upstream to downstream. For example, if a barrier has the same hydraulic conductivity as the soil has, in other words, very simple words, the same permeability of the barrier is the same permeability of the soil, then the water table, the level of groundwater, it's the same. But if we use a barrier that has a lower hydraulic conductivity than the soil, then what happens is we decrease the level of groundwater from upstream to the left to downstream to the right. And that is sometimes important to protect specific zones of the soil. But you also have the option to put a barrier with a hydraulic conductivity equal to zero, and then the problem is that the water doesn't pass through the barrier, okay, and it goes around. So we have here some examples of building barriers. Uh, in red, you have the barrier, okay. On the top, you see the top view, the sky view of the barrier in red, and the contaminated zone with the skull. And we have here, for example, a containment barrier that's containing the the contaminated zone. Here in this example, the groundwater is no longer with contact with the barrier, and the remaining groundwater that's in contact with the contaminated zone, that's inside the contained zone, can be pumped out and treated. And then, okay, you have the contaminated zone not touching the groundwater, so you can then do the proper remediation. We have here, for example, an example of an upstream barrier where the barrier is just covering the contaminated zone from the upstream. And then you can use a pump to make the groundwater do not touch the, the contaminated zone. It's like we are making the groundwater dodging the contaminated area. But for that, you need to have a barrier upstream and a water pump to. Oh, just a second. Okay. And then you have here a downstream barrier where you see that groundwater is touching the contaminated zone. You then pump out the contaminated water to treat it. And the barrier is just protecting the zone that's downstream of the contaminated zone. Okay, here's the purpose of the barrier. type of barrier that's called the downstream barrier. It's just protecting the right side, where, as you see. We also have floating barriers, which are barriers that do not touch the confining layer, the impermeable layer of the soil. Sometimes we can use these barriers, for example, when we have contaminants that float in the water, which is the case, for example, of petroleum contaminants. These are the type of contaminants where we can use floating barriers to contain the contaminated zone. The advantage of building these kinds of barriers is just because it's cheaper. You do not have to do such a deep excavation in the soil. For example, you have the kinds of contaminants that are called DNAPL, which are dense contaminants, more dense than water. Then so they can, if they are not dissolving in groundwater, the remaining part of the contaminant goes down to the base of the aquifer. While we have the LNAPL, Vanapple, which are low density contaminants, for example, uh, hydrocarbons from the petroleum industry, gasoline, diesel, which normally can float, okay? And if they float, it means that they are just on the top of groundwater. And these are the cases where we can use, for example, a floating barrier. If the contamination is made by a dense contaminant, a contaminant that's denser than water, we should use an anchored barrier because it goes from the top of the soil to the bottom, to the confining layer. While if we have a low density contaminant with lower density than water, a floating barrier is enough to contain the contamination. Uh, okay, another technology. I'm going to talk about soil vapor extraction, bioventing, air sparging, and biosparging. Uh, soil vapor extraction, it's a type of mediation that's mostly done in the unsaturated zone when we have contaminants that are very volatile or just volatile. And the principle is basically we inject air in the soil. We are injecting air and also extracting air from the soil, and we are injecting clean air and extracting contaminated air because if the contaminant is volatile, it will go to the gas phase in the air that's inside the soil. So this technology can only be applied in the unsaturated zone because it is the zone of the soil where you still have air. While in the saturated zone you do not have air, you just have water and soil particles. So it's not applicable to the saturated zone. I have here, okay, a video to explain a little bit of this technology. Okay, sorry about the ads. Okay. Okay, I cannot touch this. Okay, here goes the video. So, okay, this video is about the cell vapor extraction, where this is the same as like putting a vacuum cleaner inside the soil to drag the air that's inside the soil. So we are basically injecting clean air in the soil, and we are also extracting the air that's contaminated because the contaminant goes from the not contaminated air. It goes from the soil to the air that we are injecting in the soil, and then we extract it and have to treat it outside of the zone. And then we have a station with activated filters of carbons, filters of activated carbon, for example, to clean the contaminant. Sorry, let me just let's see. Okay, let's see. Okay, just a second. Okay, okay. Remember that the soil is a mixture of mineral particles, organic matter, solid phase, water, and air. And if we have this zone is you have this contaminated, and if we inject clean air in the soil, the we are basically cleaning the soil because we are injecting clean air in the soil, and the contaminant particles will move from the solid and the liquid phase to the gas phase. Okay, and it's like we are injecting clean air and contaminating the air that we are injecting, and then we extract that air, and the contaminant is basically being removed by volatilization. Okay, and that's the principle of the soil vapor extraction technology. We can have the air injection with a pump, normally necessary when the soil is composed by very thin particles, or we can just don't inject the air, and the air will naturally go inside the soil if it has uh, thicker particles, for example, in this example. Okay, the air supply can be forced with pumps or natural if the soil doesn't have very thin particles. And basically, when you see a soil vapor extraction process, you will see something like this. Pipes installed inside the soil and some vents with equipment to inject and extract the air and clean the extracted air. And normally these remediations can take something between 6 months to 2 years, which is something that is considered fast in the rehabilitation of soils and aquifers. So now let's talk about bioventing, which is something a little bit different than soil vapor extraction. Bioventing can only be applied in the unsaturated zone. And in bioventing, it's similar to soil vapor extraction because we are injecting air inside the soil, but the purpose of the air injection is bioventing. It's not to drag the contaminants, but to to feed, to give oxygen to aerobic bacteria, to bacteria that breathe oxygen that are inside the soil, that will be basically degrading the contaminant. They will be eating the contaminant, using the contaminant as their carbon source. And this is very common to treat zones that are contaminated with hydrocarbons from the petroleum industry. And for example, gasoline, it's very volatile. So zones contaminated with gasoline are ideal to be remediated through soil vapor extraction, while zones contaminated by diesel, which is not so volatile, are ideal to be treated through bioventing. So in bioventing, basically, we have the structure of the structure is similar to soil vapor extraction, but the purpose in bioventing is to stimulate the biodegradation of contaminants. Okay, to stimulate the biodegradation, we are stimulating the bacteria that are inside the soil, or most commonly, we inject bacteria inside of the soil that are trained to degrade hydrocarbons, and then we'll be giving them air, oxygen through the air injection, and also some nutrients to make them have a balanced diet. Okay, so yeah, we are have there we have microorganisms eating the contaminant in the contaminated zone, and we are just injecting. First, we have to place uh, microorganisms, and then we are feeding them with oxygen and nutrients. So, and this is basically the the structure of a bioventing facility where we have the air injection, the air extraction, and we also are injecting nutrients and also moisture to the soil because to make sure that the bacteria do not dry, okay, that the soil has enough moisture for the bacteria to live. Uh, okay, and let me. Okay, I will not show video here because this is quite simple to understand. Okay. Sorry, just a question. My presentation ends in half an hour, right? Or I'm not sure if it is 1 hour or 1.5 hours.
1 hour, one and a half, 1.5
One and a
hours.
half? Okay, okay, okay,
Okay,
okay.
okay.
So I have, okay, thank you. So in vapor extraction, the scheme is this. You have the air injection, the air extraction, and then you are extracting air that becomes contaminated as it's passing through the contaminated zone. In bioventing, it's the same, but we are injecting some nutrients in the contaminated zone where we have bacteria degrading the contaminants. So we can say that basically bioventing is the same as soil vapor extraction, but we are adding the process to stimulate the biodegradation in the soil. Okay, but sometimes contaminations are below the water table in the vadose zone, and then we have to do something that's a little bit different. We can inject air to groundwater, but we need pumps with higher with with higher energy consumption, and we can inject uh, air in the vadose zone, and in that case we call air sparging to the remediation process because we are using an air sparger well. And what the air sparger does is like bubbling in groundwater. And those bubbles carry air that can pass through the contaminated zone. And once more, the contaminant will go to the clean air, and then it will leave the soil through the air extraction zone. And to this process we call air sparging. Then we can also okay, so sorry. And in their sparging, what we are doing is like uh, making bubbles in groundwater, and these are the bubbles that carry the clean air that will receive the contaminant and then will leave the groundwater and soil through the air extraction process. Then, and to that full process, we call it the air sparging. Yeah, so basically the air bubbles will travel through the solid, through the mineral particles around, and the contaminant will go to those bubbles. Now, we also have the option to do the biosparging, which basically is the same as biosparging, but we are here also stimulating the bacteria that are in groundwater to degrade the contaminant. It's something a little bit harder to control, okay, with the injection of nutrients and make sure that the microorganisms have the conditions to survive in groundwater to do the decontamination. Okay, and here in this example, we are uh, basically injecting air to the soil, Two, just to feed oxygen in groundwater. And in biosparging, we can inject air or do something that's more expensive to inject directly oxygen in the groundwater. And then what happens is that the contaminant, part of the contaminant will go to the air bubbles, but the other part will be degraded by the bacteria that will have the contaminant as their carbon source, if it is a hydrocarbon, and they will be also consuming the nutrients and the oxygen in their metabolism. Something just a technical detail of the beer sparging. Since we are injecting air and oxygen in groundwater, we must be aware that the iron concentration in groundwater cannot be high. For example, cannot be higher than 20 milligrams per liter, because if it is this the case, the oxygen will promote the uh, the oxidation of the iron, creating rust. And the problem of rust in groundwater is that the rust will fill the holes in the solid particle, and then there will be no longer movement of groundwater or movement of air. Okay, and then in that and that is a big problem, because if that makes the solid part of the soil impermeable, okay, and then it's much harder to inject air and make the movement of fluids in the soil. Okay, now going for a different technology, the land farming and biopiles. Land farming and biopiles are ex situ technologies, which means that we can use them. We should use them not in the zone where you have the contamination, but take out contaminated soil and then treat it in a different site. It is totally applicable to the unsaturated zone, but it can only be applied to the saturation zone if it is not too deep. And why? Because we are excavating the soil and taking out the contaminated soil to be treated apart. And then in these processes, we are basically cultivating microorganisms in the soil to destroy the contaminants. Okay, it's like we are making the cultivation of microorganisms and not vegetables. But that's why it's called plant farming, because it's like we are farming bacteria in the soil. Let me show a video. Hope that we do not have too much publicity here. Sorry. Okay. So in one farming, we are also providing oxygen, nutrients to the bacteria. We have an impermeable floor where we put the contaminated soil, add nutrients, and then we have to do the tilling of the soil to make sure that it has enough space for the oxygen to move in the soil so that bacteria can breathe it, okay? Because these processes use normally aerobic bacteria that breathe oxygen. And it's important to have an impermeable layer down, because this process leads to the release of liquids that are also contaminated. And if the soil has an impermeable layer down, we can drain out the remaining liquids and take care of them instead of being contaminating the remaining parts of the other parts of the soil. Okay. So we have here, for example, the example of the land farming field. This is done in open air, okay? So because it's normally in vast areas, we cannot do this land farming fields very deep. Otherwise, the oxygen from the atmosphere cannot infiltrate the soil. So yeah, we this is basically the structure of a farm, but where we are cultivating the microorganisms. Um, okay, now it's normally here to extract the leach that comes from the soil, okay, and then treat it because this leach is still contaminated with hydrocarbons, for example, that cannot go to the soil, okay, and must be go to a water treatment plant. Biopiles are very similar to the land farming technology, but instead of having a vast field, you have a pile, which has the advantage of occupying a lower area, but are much harder to control and need much more equipment because you'll be injecting air in the biopiles, okay? And you must have an accurate air injection system. And biopiles are more expensive than land farming, but they also have an advantage because biopiles are covered, and so the treatment it's less exposed to the weather conditions during the process. And when farming fields in rainy zones, it's not very good because the soil will get wet and will have lower capacity to absorb oxygen. While in biopiles, since you have a polypropylene cover, you can make the protect the soil from the rainfall, for example, and you can also make a more accurate temperature control for the growth of bacteria. Okay, let's open a video and hope that we do not have more advertising. Okay, good. So yeah, we also have here the biggest difference is that we have the injection pipes in the pile, and the soil is in a big pile. We also inject nutrients and water to make sure that we have enough moisture in the pile of contaminated soil. Oh, okay. So this is just like bioventing, but outside of the contaminated zone in a controlled area. Okay, so the biggest advantage of the land farming it's the cost. Okay, if you have an available big area to do the decontamination, it's better to use the land farming. Otherwise, if you have site restrictions, yeah, then you must go for the biopiles. They are a little bit more expensive, but they also do the work. Um, okay, now leaving a little bit of the biodegradation processes, let's go for the thermal desorption. Uh, okay, just a very quick distinction of what is this of desorption. Okay, absorption is the process where a particle absorbs other particles, but just in the surface. That's what we call adsorption, when the particles stick just to the surface. Absorption with a V, it's when the particles go inside the particle. Adsorption, it's the process, it's a mixture of adsorption with D and absorption with a V, because the particles stay inside and outside of the particle. And thermal desorption, it's basically the process where we have particles that are attached to the soil particles, and through temperature increase, they leave out the soil particles. Thermal desorption can be done in situ or ex situ, okay? in situ we have to place like sticks that increase the temperature of the soil, while ex situ you basically make the soil be passing through furnaces or structures that just heat up the soil without burning. Okay, and then the contaminants leave the soil particles. And this is the example of an in situ. We just have a big structure of pipes injected in the soil, also with a system to extract the vapor of the soil. And we have the ex situ example, where you see like improvised industry to treat the soil. And of course, that the ex situ process is much more expensive because you have to dig the soil, take it out, and make it pass through the all the equipment. So let's show here the example of the thermal distortion in situ, and hope that advertising goes fast. Okay. So okay, we have here an example of a zone that's contaminated with uh, with contaminants from the dry cleaning industry, for example, the kerosene. If there is a release, so will be contaminated. And for this case, it will be treated with thermal distortion in situ. So, for example, basically there are injected tubes in the soil that heat up soil surface. And as you see, it's a very high temperature from 100 to 700 degrees. And then the contaminants that are released in the form of vapor or gas will be extracted from the like a soil vapor extraction technology example. This is not something very beautiful to see from the outside. You just see the pipe installed in the soil. Okay. And then, okay, the contaminants are extracted as the soil is heated. Okay. And the problem of this technology, the biggest problem is that you lose the organic matter in the soil because you are basically sterilizing the soil by heating it up, and it takes at least some 5 years of treatment of the soil to recover the organic phase with mulching treatments and so on. Uh, okay, now we have the ex situ example of thermal distortion, where basically it's the same process, but we are taking out the soil from the site. Here the process is the volatilization. So okay, so I just okay processing the soil particles into this is the disturber where the soil is being heated up. Okay, and as the soil is being heated up, contaminant particles are leaving the mineral solid particle. And then they lose all the organic matter that's in there. And then okay, the gas is burned and then you can use it to build energy. And then you have to treat the gases, and then the treated soil must be recovered to regain the the organ the of the organic content that it lost during the burning process. Okay, we also have the example of soil washing, and soil washing is something very expensive to do. Basically, when you have a contamination below the water table, for example, we inject the soil with chemicals that will be cleaning, destroying the contaminant, but then downstream, you have to immediately take out those contaminants from the groundwater and treat it. Okay, so it's like we're injecting contaminants in one direction that are destroying the contaminant, and then you are taking out the remaining of the flushing solution, of the solution that's cleaning the soil. You have to take it out, and this is okay something expensive to be done, and even in some cases can be done ex situ. Let's show here an in situ example. Uh, okay, another ad. I'm sorry. Okay, so you basically have a tank with a flushing solution that will be injected in the soil. So you inject solution from one side and then you extract it from the other, okay? And in this kind of technology, you can use any kind of fluids as long as you make sure that you have a good extraction system, okay? So it's kind of simple. And the ex situ, the example is like you build um, like a small industry to clean the soil, okay, instead of doing it inside of the soil. It's more expensive, but sometimes it's necessary when you have a lot of inside limitations. As for example, if a soil is very impermeable to the passage of fluids. And then, okay, here the example of the soil washing as situ. You just build a mount a system to drag the soil, make it pass through the flood through the cleaning solution. Okay, where you are mixing the soil with the cleaning agent and the oxidation fluid or something, depending of the type of contaminant. And an important process to do is to have some sludge that will remain from the soil, and you should always like dry it. Okay, make sure that you squeeze the water. Otherwise, you have a big volume of mixture to discard or to treat for this case. So, uh, and we also have the example of electrokinetics, which is a process where we that is very used to decontaminate soils from metals and heavy metals due to the to the charge of these elements. Because in electrokinetics, we are basically passing electric energy from the soil, creating a field and a flow of particles that go from the cathode if the particles have a positive charge, or to the anode if they have a negative charge. And this is the just an example of technology to deal with heavy metals. We also have the example of the monitored natural attenuation. Uh, Natural attenuation is just a natural process. It's not a technology where the soil, by its natural properties, can remove the contaminants. Okay, but since it is a natural process, it's a slow process, and we have a lot of processes that happen in the soil that can lead to the decontamination of sites. But the thing is, monitor natural attenuation can be called a process, a technology, where we just check if the soil is removing the contaminant. There are rare cases where we can apply this, just cases where the contamination does not have a high risk to be spread across groundwater, for example, or if it is in a zone that doesn't need to be remediated in a very short time, or if it is very far away from cities or protected areas. Sometimes we can use monitor natural attenuation as our technology, and monitor natural attenuation is just observing if the soil is doing the decontamination of uh, by itself of the contaminated areas. Of course, that we should always remove the biggest source of contamination, and then let nature decontaminate the soil by itself. Okay, we have a lot of processes that can lead to the decontamination from the reactions with the minerals that are in the soil, for example, with the bacteria that are inside the soil, and so on. And then the last technology that I'm going to talk is phytoremediation. Phytoremediation is like natural attenuation. It's a very slow treating process that it takes a long time. Phytoremediation and monitor natural attenuation are technologies that take, in overall, at least 5 years to decontaminate the site, or even decades to decontaminate the site, because these are natural processes. They have the advantage of being very cheap. Of course, you need a very low budget for the treatment. Um, but in the other hand, it will take a lot of time to do the process. And phytoremediation is basically using trees, plants, grass, or wherever, any type of green life to decontaminate a soil. And the plants are very important uh, are very special because they can decontaminate the a soil or even a groundwater through very different mechanisms. Okay, um, we have here, for example, the use of plants to decontaminate contaminated water. Okay, where you have these plants floating, and as these plants are in contact with the water, they will be removing the contaminants from the water. We have here the example of the uses of plants in a mine waste industry file that we have here. Then with time, the plants and trees could basically restore the soil, reducing the concentration of heavy metals. Okay, in this case, where is the example of cadmium. And at the same time, here, phytoremediation could do some recovery of the landscape in that area. Uh, so we have a lot of different processes. We have, for example, down, we have the phytostabilization, which is, for example, with reactions of what happens in the soil by the presence of the plant, the contaminant becomes less movable. For example, making a metal that's dissolved in groundwater into a state that is a precipitate, that it becomes a solid, We have the phytotransformation, um, where the contaminants are transformed in roots into something that is less dangerous for the environment. We have the phytodegradation, for example, when the plant takes the contaminants from the roots to the leaves, and then, for example, with the sunlight that the plant catches, the contaminant is degraded in the leaves. We have the phytovolatilization, where the plant absorbs the contaminant and then the contaminant volatilizes during the evapotranspiration process. We have the phytoextraction, which is basically the plant uptaking and draining the contaminant from the soil to the plant. And that can happen in any part of the plant, in the leaves, in the roots, or any other place. And that's my quick resume of remediation technologies. Thank you.
Thank you, Antonio, for your presentation. So let's see if we have any questions here regarding this presentation. No questions here. Let me just check
Okay.
if there is any questions online. I think we don't have any questions here. Thank you, Antonio, again. So we'll
Okay.
move for the next presentation. We hope you can keep here with us watching.
Okay. Thank you. Bye.
Okay, thank you, Antonio. Our next presenter is Ljubodrag Samardzic, and he will talk about understanding the complex air pollution, climate change, agriculture relationship.
Yeah, I hope so. Good morning, everyone. I'm here to talk about the complex and understanding the complex relationship between air pollution, climate change, and agriculture, and importance for Montenegro is process toward European Union accession. Throughout this lecture, we will discuss the baseline challenges, sources, and monitoring of air pollution, observe trends, projections, and impacts of climate change, the role and challenges of the agricultural sector, and the nexus or interconnectedness, how air pollution impacts agriculture, or climate change impacts agriculture, and And the feedback loop between three of them and policy implications. And at the end, we will give some recommendations for strengthening monitoring controls. In conclusion, as a call for coordinated action between a lot of stakeholders, governance, and NGOs and institutions, scientific universities, and so on. Air pollution remains a significant environmental and public health concern in Montenegro, according to 2024 reports run by the Environmental Protection Agency and Institute of Hydrometeorology and Seismology. So we need to address the air pollution in regards to climate change and agriculture, and to make them more connected and interchanging. So Montenegro unique context is what's to make this topic like an environmental trilemma, because there's diverse geography in Montenegro, ranging from the Adriatic coast to fertile plains to rock mountains. That unique context. So while economically Montenegro is service-dominated economy, especially from tourism, agriculture plays a vital role in the rural livelihoods, whereas a lot of people employed in agriculture, but agriculture as a sector has a small GDP contribution. As I said, according to 2024 report run by EPA and Institute, the key pollutants in Montenegro are particulate matter, PM 2.5 and 10, nitrogen oxide, sulfur dioxide, and ground level ozone. PM 2.5 and PM 10, these fine particles are major concern, primarily originating from the coal-fired plant, residential heating and road transport. And there is, as you will see, a frequent winter exceedances in urban areas like Podgorica, Bielopolje, and Lis. Nitrogen oxide, primarily an urban issue, largely attributed to traffic and combustion. They are generally lower than PM particles, but they have contributed to overall air pollution degradation. Sulfur dioxide are mainly the main source for sulfur dioxide are industrial heating sources, and since Montenegro made a commitment to reduction of these gases, we are in the process to this policy making to lower the guideline levels. And ground level ozone is the secondary pollutant. Is formed through complex chemical reactions involving other pollutants and sunlight. Ground level ozone poses significant risk for human health and vegetation. According to estimates by Institute of Public Health, significant premature mortality linked to PM 2.5 are 1,080 premature deaths per year. So for nitrogen dioxide, 60 deaths per year, and for ground level ozone, 80 deaths per year. Major sources of air pollution in Montenegro are, you can see in the table the annual mean value for main pollutants and the key observations for Podgorica, Bielopolje, which is a key spot. In Podgorica, you can see the PM 2.5 and PM 10 exceeds World Health Organization guidelines level. Bielopolje, and which are other significant spots for air pollution. For major sources of air pollution in Montenegro are diverse, are interconnected. The major sources are coal-fired power plants in general, residential heating, because most of the Montenegro houses still use the biomass of coal for residential heating. This is the major source for winter exceedance of particulate matter 2.5 and 10. Industry, transportation, especially extremely large cities for Montenegro, like Podgorica, is growing rapidly, and there's a lot of cars in Podgorica, which contributes to level exceedance of NOx and PM particles. Waste management, the controlled burning of waste contributes to range of air pollution, and agriculture as a sector itself contributes to air pollution through ammonia, methane, particulate matter particles from waste burning or from kiln. National Air Quality Monitoring Network in Montenegro is managed by two institutions, Environmental Protection Agency and Institute of Hydrometeorology and Seismology. This network is designed to meet both national and European Union regulatory requirements, especially with the EU Air Quality Directives and MF or CALTRA protocols. EPA network is automatic monitoring. They have automatic monitoring stations, 9 of them and 1 mobile station that is distributed across 3 quality zones to ensure representative coverage. In the north zone, there is 1 station in General, another one in Gradina, 1 for urban, other one is for rural, and it's still appointed also urban. In central zone, in which there is a urban station. In Podgorica, there are 2 stations, one in block 5, it's urban, and one on the roundabout in Davilo, it's urban traffic influence. And there's the one rural one in Gornja South zone, there are 2 stations, in Vara, urban one, in Kotor traffic influence, it's also urban. And as you can see on the slide, you can on the Environmental Protection Agency website, you can monitor air quality in real time. The data are not validated. The validated data you get only when they put the official report. So you can watch the real-time data for every station, including the mobile ones, which are currently located near the northeast part of Montenegro. Regarding institute, we have currently 70 certification stations located on the main meteorological station, and we have a station for transboundary air pollution located well in the list. We used to have until 2008 network of air quality stations, but it was outdated and a lot of equipment. So on these precipitation stations, we measure chemical composition of precipitation and the volume of precipitation, including chemical composition like calcium, magnesium, carbonate, pH values, and other 17 parameters of precipitation. We measure the rain, snow, even a dry precipitation using a bulk method. It's a method with on a low picture. When you have like a funnel and you select rain and snow for dry deposition, there is no raining. You use the ionized water and across the panel was put it, and you use the chemical testing. MF station in Vellinger, it's on a picture on the right. It has the automatic equipment for measuring transport air pollution, for sulfur dioxide, nitrogen oxide, and ground level ozone, including weather parameters like temperature, pressure, and winds. So what are the challenges that we are facing? That all the equipment are not all, but most of the equipment are aging, and we have a lot of gaps in recovery in Montenegro is a whole country in our network, including our IPA. So we need to expand and to put more automatic monitoring stations and maybe one more transboundary air pollution range. Montenegro efforts in air quality management are increasingly aligned with European Union directives, reflecting commitment to effective implementation of environmental protection as a part of the European Union assessment. Regarding climate change is profoundly impacting Montenegro. It's observable trends, and the projection indicated significant alteration to climate. These changes have been far-reaching consequences for various sectors, including agriculture, water resources, and public health. Montenegro has experienced clear and concerning warming trends of plus 0.03 degrees per decade from 1950 to 2020. This warming is even more pronounced in the summer, with the accelerating rate of 0.27 degrees per decade. The year 2024, for instance, so Montenegro average temperature was 1.9 degrees centigrade above historical norms, with Podgorica experiencing 90 tropical days with temperatures equal or higher than 30 degrees. While the annual precipitation ranges from 73% for normal below foliage to 105% exceptional. Fresh and water resources critical for irrigation, which are frequency of both floods and drought risk, increasing floods and drought risk, and the frequency of extreme weather events, including heat waves, droughts, and heavy rainfall, has demonstrably increased in Montenegro. These events have severe social and economic impacts affecting agricultural productivity, water availability, and infrastructure. As you can see, there's on the slide, there's a temperature and precipitation percentile distribution for 2024, where you can see that 2024 is one of the hottest years since the measure started. And you can see the actual warming trend from 1950 to 2020, and even seasonal cycle of air temperature distribution. As you can see, there is a incline in temperature in all seasons. And using historical data from institute and graph representation from Aero 5, you can see on the graph representation the temperature precipitation throughout the years from 1991 from 2014, and there you can see clear trends for increased the temperature and erratic precipitation throughout decades. Regarding projections for future climate projections for Montenegro, there's indicating continuation and intensification of these trends. There's continual warming and erratic precipitation, sea level rise. There's the changes in seasonal winter and summer and annual temperature and precipitation. If you see for the period from 2011 to 2040, 2041 to 2017, 2071 to 2100, compared to the period of 1971 to 2000, according to the RCP 8.5 scenario, a high emission scenario, there's substantial changes in both seasonal and annual temperature and precipitation. And these projections highlight the urgency of implementing robust adaptation and mitigation studies. Regarding economic impact, climate change is anticipated to have significant economic repercussions. For example, potential GDP reduction will be 7.5% by 2050 due to climate-related disasters. This impact will not be uniformly distributed. There's a regional variation. For example, coastal areas will face increased risk of heat stress, the water scarcity, and sea level rise. Central plains, the key agricultural regions of Montenegro will experience heightened agricultural water stress due to altered precipitation patterns and increased temperatures, while the mountainous regions will see impact of snowpack and water resources affecting downstream water availability. Several sectors are particularly vulnerable to climate changes, that are agriculture, water resources, health, and tourism. Regarding tourism, a vital sector for Montenegro economy, vulnerable to climate changes because of the incline of heat days and the degradation of natural attractions that are mainly like landmarks for Montenegro for tourists. Regarding health, public health is risk for heat-based vector-borne disease like ticks and mosquitoes, and air pollution is exacerbated by climate change. In this section, we will delve into agricultural sector, their roles and challenges. Agriculture in Montenegro, despite its relatively smaller contributions to annual GDP, plays significant role, especially in rural livelihood. As a contributor of food security, as an integral part, as a cultural heritage, and as a tourism link in agritourism as a sector. What are the characteristics of Montenegro agricultural sector? In the rural livelihood, there's high employment. There is diverse land use, coastal plains and mountains, which with a specific crop of livestock stone. There is a food security contribution, while Montenegro still is reliant on a food import. Domestic agricultural production contributes to national food security. And as a cultural heritage and tourism link, we already said, traditional agricultural practices and landscape are deeply intertwined with Montenegro's cultural identity, agritourism, and the production of local traditional food also further the significant attraction for the virgin community. Montenegro developed geography translated into various agricultural practices and specific crop livestock zones. We can, as we said, see there are 3 zones: coastal plains and mountainous regions. Coastal areas are characterized by Mediterranean cross-cultivated growth and early vegetable production. Central plains known for more intensive agriculture, including cereals, vegetables, and food sources. And mountainous regions are dominated by livestock and especially cattle and sheep, farming, and cultivation of agriculture. Despite the importance of Montenegro agriculture is facing several systematic challenges. The challenges are we have in Montenegro a small farm size and fragmentation, which limits economies of scale and adaptation of modern efficient farming. There is a problem with the market access, both domestic and international, due to underdeveloped infrastructure, weak supply chains, insufficient processing capacity. There's trade imbalance. Montenegro is reliant on food imports, creates a trade deficit. There's a soil and water issue, especially land degradation, soil erosion, and in addition, water management practices pose significant threats to the agricultural sector. And there is also rural depopulation. The ongoing trend of rural to urban migration leads to decline in agricultural workforce and abandonment of small farms in up north of Montenegro. Regarding policy context, Montenegro agricultural policy are increasingly focused on aligning the European Union Common Agricultural Policy, known as the CAP. This involves a shift towards rural development, emphasizing sustainable practices, environmental protection, and support for small and medium-sized farms. In this chapter, we will discuss about interconnectedness or the nexus, how air pollution impacts agriculture. As you can see on the picture, there are mechanisms of impact with the deposition of PM2.5 or PM10 particles. They settle on a plane surface, and it physically blocks the matter, which is a tiny portion of leaves that are responsible for gas exchange. This blockage reduces the plant force and the ability to photosynthesize. The accumulated dust and particles can also reduce light penetration to the leaf surface, further impeding photosynthesis and overall plant health. Regarding ground level ozone damage, is particularly unlike stratospheric ozone, which protects us from the harmful UV light. Radiation, ground level ozone is powerful oxidant that can directly damage plant tissue. Exposing to higher concentration of ground level ozone can lead to visible injury of the leaves, such as chlorosis or yellowing or necrosis or browning or premature leaf senescence or aging, and a significant reduction to photosynthetic capacity. Regarding acid deposition or pollutants like sulfur dioxide and nitrogen oxide, which can contribute to acid rains. In last 3 years, we have a decline in occurrences of acid rains. In 2022, I think it was the time in 2023 to 22, and in 2024 only 11 times the dusting rains were dropping from it. So acid deposition can alter soil, change pH value of the soil, and leach essential nutrients from the soil and release toxic chemicals. What are the consequences of the air pollutants and their impact on agriculture? Reduced crop yield and quality. That's the most direct and measurable effect. Economic losses for farmers, especially for small scale farmers. We have limited buffers against such losses, and threats to rural livelihood because degradation of agricultural productivity due to air pollution can make people leave the rural livelihood and go to urban or migrate. Regarding regional focus, areas in close proximity to major sources of air pollution are likely to experience more pronounced impacts. For instance, agricultural region near urban centers with high traffic density, or industrial zones such as Zeta Plain near Podgorica are potentially more affected by particulate matters, NOx, or ozone pollution. And understanding these localized images is crucial for targeted intervention. Next, we will explore how climate change impacts agriculture. Climate change, which is multifaceted impacts of temperature, precipitation, and extreme weather events, directly and profoundly affects agricultural systems. For example, heat waves, increased frequency, intensity of heat waves can directly affect to reduce photosynthesis, accelerate plant maturation, or even flower abortion, or reduce grain filling, all contributing to low yields. Or for livestock, heat stress can decrease fertility, milk production, or overall health. Regarding droughts, longer and more frequent dry spells are projected trend for Montenegro in the future years, lead to water scarcity for irrigation, reduce soil moisture, and increase risk of crop fading. Regarding floods, more intense rainfall events can cause flash floods, leading to soil erosion, or even waterlogging of crops and damages to agricultural infrastructure. Regarding changes in water availability, climate change directly alters hydrological cycles, shift in precipitation patterns, including reduced snowpack in mountainous regions and changes in river flows lead to water shortages. Regarding increase in pest and disease, warmer temperature and altered humidity patterns can create more favorable conditions for the proliferation and spread of agricultural pests and diseases. Milder winters may allow pest population to survive and expand. So, leading to increased crop damages and need for more intensive pest management. Regarding reduced crop yield, the cumulative effects of these climate impacts is reduction in overall agricultural productivity, lower yield, diminished crop quality, and increased variability in production directly threatens food security and the economic viability of the farming community. This can lead to higher food prices, increased reliance on imports, and reduced income for a small farm. In this chapter, we will discuss how agriculture, which was the victim in last two chapters, is now contributed to air pollution and the climate change. While the agriculture is, as we saw, significantly impacted by air pollution and climate change, it is also a notable contributor for both. To air pollution, agriculture contributes to ammonia, methane, particulate matter, and nitrogen oxide. Ammonia is a source of ammonia that, which is a major pollutant from agriculture, primarily originated from fertilizer and from manure, and is a precursor for secondary particulate matter. 3.5, meaning it reacts in atmosphere and forms fine particles that are harmful to human health and the plant. Regarding methane, of livestock, especially cattle and sheep, produce significant amount of methane to enteric fermentation or digestion. Regarding particulate matter, agricultural practices like waste burning or silage, plowing or harrowing can release particulate matter into the air. And regarding nitrogen oxide, while primarily associated with industrial and transport sources, agricultural machinery like tractors or harvesters also contribute to NOx emissions to fuel combustion. As a contribution to the climate change, agriculture is a significant source of greenhouse gas emission, contributing directly to climate change. You can see the methane and nitrous oxide and carbon dioxide as the greenhouse gases. They have the same source mentioned before. As for nitrous oxide, it's primarily emitted from agricultural soil due to application of nitrogen fertilizer and soil management. Regarding feedback loops or relationship between air pollution, climate change, and agriculture, which is not a simple or linear one. It's rather characterized by complex feedback loops. Let's discuss these key loops. Air pollution impacts agriculture, leading to more emission. As we discussed, air pollutants like PM and ozone reduce crop yield and quality. This can incentivize farmers to intensify production, which leads to using more fertilizer and expanding land use. It's a cycle that eventually increase more emission, which worsens air pollution and climate. Regarding climate change, worsens air pollution, which further impacts agriculture. Climate change can create conditions that worsen air pollution. For example, increased temperature and prolonged dry periods can lead to atmospheric stagnation, trapping pollutants at the ground level. Heat waves accelerate formation of ground level ozone. Droughts increase the risk of wildfires and dust storms, releasing a large amount of particulate matter. These worsen air quality conditions then further impact agriculture. Certain air pollutants like black carbon, which is a component of particulate matter from incomplete combustion, also short-lived climate pollutants, but black carbon can absorb solar radiation, contributing to atmospheric warming, accelerating ice and snow melt when deposited on surface. This direct contribution to climate change then feeds back into the climate change impact on agriculture. and the climate change impact lead to changes in agricultural practices or with emission consequences. As the farmer adapts to climate change impacts like drought, they can start using drought resilient crops, or they can use if they are using standard crops, they can use more water for irrigation, which will eventually increase energy consumption because of the pumping water, and there's always emission from the pumps, and the place further stress on the water resources. So eventually alter emission profiles and shift to more intensive regime. So the method for the feedback loop and policy application will be siloed approaches are insufficient, so integrated understanding of the regarding core principle of effective policy is to address air pollution, climate change, food mitigation and adaptation, and agriculture, sustainability concurrently. This requires a shift from sectoral thinking to integrated cross-sectoral management framework. As a necessity, integrated approach is necessary to avoid unintended consequences and maximize co-benefit. Regarding framework leveraging a European Union assessment process and directives, Montenegro European Union process provides a powerful framework for driving this integrated approach, alignment with the EU directive, and on air quality, climate action, and sustainable agriculture offers a structural pathway for policy development and implementation. This includes directives like National Emission Ceiling Directive, the Industrial Emissions Directive, and various CAP regulations. As for a challenge, the primary challenge in implementing an integrated approach lies in fostering effective cross-sectoral coordination, breaking down institutional silos. In the next section, we'll examine specific policy and goals for Montenegro, which are relevant to this integrated challenges. As you can see on the slide, we, as a country, it has recognized the urgency of addressing environmental challenges and has established several key policies like National Determined Contribution, NDC, Montenegro National Communication Climate Changes, NAP, National Adaptation Plan, Air Quality Management Strategy, and strategy regarding renewable energy. In NDC update of 2024, Montenegro is committed to significantly reducing its GHG gas emissions. The update sets ambitious targets, 55% by 2030 compared to 1990, and 60% by 2035, including the land use, the change and forestry sectors, acknowledging the role of land management, agriculture, and climate mitigation efforts. Regarding Montenegro National Communication on Climate Changes, there has been 3 so far communications. The fourth is in the process of publishing. They serve as a foundational report concerning Montenegro climate action efforts and progress. They provide comprehensive information on country greenhouse emissions, vulnerabilities to climate change, and action taken to address climate change, mitigation, and adaptation. regarding national adaptation plan. The plan prioritizes climate resilient agriculture, water management and health, and it's supported by international climate finance mechanisms such as the Green Climate Fund. Regarding air quality management, it's still in a draft in 2021. It's not approved. We were waiting for Montenegro energy plan to be finished to conclude the air quality management project. And it is designed to follow the stringent guidelines set by the World Health Organization for PM 2.5 NOx and sulfur dioxide. The implementation of this strategy is critical for improving public health and reducing negative impacts on air pollution, on agriculture and climate change, and all ecosystems. Regarding renewable energy growth, as a part of the project broader energy transition, Montenegro has set a target of achieving 50% of renewable energy by 2030, to shift away from fossil fuels, particularly coal, will have significant benefits on air pollution and also agriculture and the climate. These policies and goals demonstrate Montenegro's commitment to a more sustainable and resilient. Regarding recommendations, to be more effective, we need to strengthen monitoring and control between air pollution, climate change, and agriculture. We must implement a comprehensive set of recommendations, focus of monitoring and research, emission reduction, climate smart agriculture, governance, and finance. Regarding monitoring and research, it is crucial to upgrade and expand the air quality network, especially in rural or agricultural areas, especially for pollutants like ammonia or PM 2.5, which are very characteristic for agriculture. We need to improve greenhouse gases emission inventory for agriculture in collaboration with the Environmental Protection Agency. And we need to understand the EU syntax and make research specific research which agricultural practices or air pollutants make the highest contribution in Montenegro. Regarding emission reduction, this is a cross-sectoral goal, which or recommendation, which is being done cross-sectorally. Regarding industry energy, we need to strictly enforce existing controls of implementation of new measures to reduce sulfur dioxide, nitrogen oxide, of PM particles. We need to promote cleaner fuel efficiency. As you can see, last few years there has been action or call for houses to use cleaner energy. There's a lot of houses with solar panels or transforming from biomass or coal to electric heating. And regarding transport, we need to promote public transportation and we use more electrification or enforce strictly emission vehicle standards, which are, but it's not implementable really, because most of the cars that we drive here use cars from European Union that has a high emission and pollutant. They are not used new cars. So we buy cheap new cars for it. Regarding climate smart agriculture, it is very important to promote climate resilient practices, which means to support and encourage farmers in adopting practices that are drought tolerant or water efficiency, especially in irrigation, or to diversify cropping system, to optimize fertilizers and manure management, even in order to reduce nitrous oxide and ammonia, and to eliminate agricultural waste burning and for conservation and agriculture or agriculture. Regarding governance and finance, we need to develop region-specific strategies. We can't use a one-size-fits-all approach. We need to have every geographical or agricultural characteristical region to have his own approach. We need to enhance institutional capacity for integrated management, which means to strengthen the capacity of relevant institutions like the Ministry of Agriculture, Ministry of Environmental, institutions like Environmental Protection Agency, Institute of Federal Meteorology and Seismology. And regarding mobile financing, we need to be more involved in European Union funds like adaptation fund or green climate fund, or in order to invest in the sustainable agriculture, clean energy, or modern monitoring infrastructure. And for a conclusion, to summarize through all these slides, we can have one key takeaway. Interconnectedness is the key, which means we need to understand that there is no there's no siloed approach. You need to have integrated approach and address agriculture, pollution, and climate change as the one. There is a significant impact of agriculture, and agriculture is both in the victim and contributor. And regarding policy framework, Montenegro established a robust policy framework, including ambitious NDC targets, air quality management strategy, and the NEP, but challenges ineffective implementation. The urgency of addressing these interconnections cannot be overstated. We need a joint effort. This requires research and understanding, continuing investment in scientific research, and deepening knowledge about complex relationships between the three sectors in context of Montenegro. We need to strengthen collaboration and partnership among all the stakeholders, farmers, scientists, policymakers, and other stakeholders. And we need implementing integrated solutions or apply integrated approaches that promote sustainable agriculture and improve air quality for the benefit of environment and the human health. Regarding the role of ICT, Institute of Hydrometeorology and Seismology, The Institute plays a pivotal role and indispensable role in this process. As the primary scientific institution responsible for monitoring and accessing climate and atmospheric conditions, Institute provides climate modeling, early warning systems, policy support, and comprehensive monitoring. To climate modeling, we provide detailed long-term projections for temperature, precipitation, extreme weather events, informing crop selection and irrigation plans. These models are becoming key for adapting agriculture to Montenegro. To early warning systems, we provide weather forecasts, air quality monitoring, pollution hotspots, and issue alerts during snow episodes. This function is critical for protecting public health and agricultural resources. Through policy support, we collaborate with DEPA and other governance agencies to validate greenhouse gas inventories and track progress towards NDC targets. This collaboration ensures science-based decision making, and for comprehensive monitoring, we monitor soil temperature, technology at the different depths. The technology and maintaining a network of resources across Montenegro providing vital data for drought monitoring and accessing climate change, extreme events, impact, and vulnerability. And if you visit our portal, www.meteor.me, you can find all the information, including agricultural bulletin or temperature, precipitation trends, or detailed long-term projections, or even numeric or model projections for climate change. Since Montenegro stands at the critical juncture, it is going to see addressing interconnections between air pollution, climate change, and agriculture. Only through joint efforts and practical measures we can mitigate all the negative effects on the environment and human health. Montenegro has the opportunity to become a leader in sustainable agriculture that contributes to cleaner air and more resilient to climate changes, creating a model that another countries in the region can follow. The Institute of Hydrometeorology and Seismology has a key role in this process, providing scientific support for informed decision and supporting the development of effective strategies for sustainable. Thank you. I'm not used to academic English, so I hope you understand. Is there a question?
Thank you for a nice presentation. Do we have questions? No. Okay. I have one question. Related to the cooperation between agriculture producers, policy makers, and research. In your opinion, what is the best approach in order to strengthen this cooperation? Since you know how we can increase the awareness to the agriculture producer of the importance of collecting and processing.
I don't get an opportunity to show you the portal, but on our portal there's a report for very important for farmers, where you can see the technology of soil temperature on different depths, and you can see when it's the right time to how to say, plant the crop, something like that. So I think we need to make the Ministry of Agriculture, the center, and the agencies like institute or stakeholders like farmer representatives to work together and make some to be small part of our portal or different portal where they can find all the information important for agriculture, for even extreme weather projections or drought or floods or even other meteorological built-in or something like that, so they can be informed in the real time about the time doing the.
And also one question more. Are there some government regulations that are related to the reducing of the carbon footprint to agriculture producers?
We'll be implementing the new NDC update and air quality strategy. We are a little bit behind because we were waiting on Montenegro energy plan, which was approved half month, 6 months ago, I think. And because we, according to that plan, you can find the projection for future development of Montenegro hydropower or some other power plant, and we do provide them. We use their projections to project our need for our strategy. So I don't know if I'm clear, but
Yeah, I understand. And I have one silly question. Since the institute is highly dependent on the sensing equipment, and the most of your automatically taken the data are taken by some kind of sensors. Have you ever considered to found some kind of research department within the institute that will do with the developing of some sensing technology and some similar? It's really hard.
yeah. As the institute, we have different sectors, and it's not a lot of men to work there. So basically, if the sensor is validated and follows the reference of standard method, it can get a good range of values that can be used for estimation of water or air quality or something. We are always using sensors. So how to say it, in complete department of air quality, there's 5 people. Complete department of water quality, there's 6 people. And if you see the plan and program for monitoring the water, there are so many rivers and streams and groundwater, and you can't actually, it's not possible to do all. If the air quality is the same, with the phenology is the same. We have reporters on every meteorological station that report about the soil temperature, about I don't know how to say, changes in crop flowering the plants. We have I don't know how many plants that we follow. And
It is really hard.
it's hard. We had a little more financing, and we had a little more people with the footprint.
Yes, but I believe that you have opportunity through some European funding projects to establish some kind of infrastructure.
But in order to employ one person, if we are public, we need the process that around 8 months. And when you finally get something there, vacancy, no one is going because the salary is too low for that. They say they can make 2 or 3 salaries like that, like tax would rise. So it's a vicious cycle. I know. Okay, I think it's time for coffee break.
Okay.
Early coffee break.
Okay, thank you, Luberak, for your presentation and answers. Now, according agenda, we have a coffee break. For people who follow online, we will be back in around 30 minutes. And now you are all involved to join on coffee break. Thank you. Okay, now we can continue. Our next presenter is Ljubica Vulovic, and she will talk about integrated water management in Montenegro.
Hello, everybody. My name is Ljubica Vulovic. I work in Institute of Hydrometeorology and Seismology of Montenegro, and my today's topic is integrated water management in Montenegro. That's not okay. Here is the chapter. First introduction, integrated water management, something about the regulation in the legal framework. Then water resources in Montenegro, different types of water, water protection and quality of water, protection from water, and in the final financing of water sector. It's still not. Oh, yes, please. First, let's say something about the water. Water is not only a substance that flows out of surface or drip from the sky, it's necessary for all forms of life on Earth. It's a key factor in the sustainability of our planet, a carrier of life, the guardian of biodiversity, and the reminder of the fragility and importance of preserving our natural life. Today, as we are facing challenges such as climate change, urbanization, and the water scarcity, integrated water management is becoming increasingly important. This holistic approach balances environmental, social, and economic needs by considering every aspect of the water cycle: drinking water, wastewater, stormwater, and irrigation, while promoting sustainable use and conservation. It encourages collaboration between governments, industries, and the communities to develop strategies that ensure long-term water security and ecosystem health. Integrated water management includes the coordination of all aspects of water resources management to achieve a sustainable balance between ecological, social, and economical needs. Water management is based on the 10 principles that are listed in water law of Montenegro. The responsibility of water as resources and traditional systems, integrity of all processes in nature, because water is an integrated component of the ecosystems, unity of the water systems based on integrated water management within ununified water area. Sustainability is to ensuring water resources are used responsibly to meet present and future needs. Equitable access, providing fair distribution of water to all communities and offices and companies. Long-term protection of the quality and rational use of available water resources. The right to protection against the harmful methods of water, economic valuation of water, public participation, and consideration of the best available technologies and new scientific achievements regarding natural law. Series of operational goals and tasks have been set and must be achieved within the framework of water management. It is to ensure sufficient drinking water quality for public water supply for population, ensure the necessary quality of water appropriated for various economic needs, protect people and materials from the harmful effects of water, achieve and maintain the good status of water to protect aquatic and water-dependent ecosystems. Activity arising from these basic objectives are rational use of water resources, planning and managing water resources at the high and professional level, avoiding conflict between interesting groups, significant participation of interested groups in the population in the planning and management process, strengthening institutional, financial, and other mechanisms that should enable the implementation of the productive plans. Since 2000, Water Framework Directive can be the main law for water protection in Europe. It applies to inland, transitional, and coastal water, surface water, and also groundwater. The main goals are achieving good status of water resources, preventing further deterioration of water status, protection, improvement, and restoration of all water bodies, promoting sustainable water use, the progressive reduction of pollution from priority substances, and gradual elimination of discharge emissions and water from priority substances, progressive reduction of groundwater pollution, mitigate the effects of floods and droughts, achieving the standards and goals set to the protected area. Water Framework Directive promotes integrated water management with a holistic approach focused on river basin district and ecosystem integrity. This includes integration of environmental objectives, integration of all water resources, integration of all water uses, integration of disciplines, analysis, and text technologies, integration of water legislation into common process, integration of integration of private, state, and private. To different member states in the water net. Besides this directive, there is several other directives that is linked with it. The water wastewater directive, groundwater directive, discharge directive, flood directive, drinking water directive, directive on environmental quality standards, and basin water directive. The water law is a framework law in the water sector and responds to principles of water framework directive into Montenegrin legislation. It defines a legal framework for integrated water management, including ecosystem protection, sustainable use of water resources, and pollution prevention. It indicates management based on access to the river basin and regulates water ownership, water management planning, water regulation and use, water infrastructure, water monitoring, floods, and erosion protection. It is applied to surface water, groundwater, water, mineral, and thermal water. Force feeds integrated water resource management and regulates water usage as well as activities that may negatively impact water conditions. Force feeds the protection of water from pollution and protection against harmful effects. Legislation has various law, acts, and regulations, spanning multiple administrative levels that govern water use, protection, and management. These legal instruments enable cooperation among different sectors: agriculture, environment, industry, energy, ensuring the coordinated approach to water resources. The framework regarding encourages the development and adoption of innovative technologies and practices that promote sustainability and effective use of water resources. The state is ultimately responsible for water management. It adopts all normative documents and policies to maintain the unity and integrity of the national water system. Some other important laws that water law is law on water management financing, law on urban wastewater management and special planning, law on providing healthy water for human use, law on freedom approach to activities and the others. Also important documents are water management strategy, Adriatic endangered river basin plan, project management and institutional framework of water sector is fluid, and there is two levels, state level and local level. Government of Montenegro adopts the K planning document, visions and normative acts related to water management. Establishing the form executive bodies and organizations vital to the water sector. The main ministry in this water management is Ministry of Agriculture, Forestry and Water Management and Directorate of Water Management. Then it's the Ministry of Ecology with Directorate for Ecology, Directorate of Natural Protection, Agency for Natural and Environmental Protection, Water Administration, Institute of Hydrometeorological Technology, Center for Ecological Testing, and Ministry of Health with Institute of Public Health, Ministry of Interior with the Directorate for Emergency Situation, Ministry of Energy, Ministry of Transport, Maritime Affairs. On the local level, it's a municipality, water supply company, local secretariats for the ecology. Water resources in Montenegro is potential of the water resources is for the mega development potential of Montenegro. There is some rivers, lakes, sea and groundwater. Relatively to its surface area, our country ranks among the most richest areas in the world. But 35% of territory suffers from chronic water shortage, and around 10% are facing the issue of seasonal water shortage. Special arrangements of surface and groundwater, as well as their interconnection, primarily to facilitate by the morphological and hydrological conditions of the area. Almost 95% of rivers in Montenegro originate within its territory. It means that their source and catchment areas are located in our country. The country is divided into two watersheds. Danube watershed approximately is 52% of territory, and the Adriatic watershed approximately 47% of our territory. The delineation of water bodies was one of the first steps in the implementation of the framework. In total, it was proposed that there will be 99 surface water bodies in Montenegro. In that upper slide, you can see the delineation of river water bodies in our country. Montenegro is located in two ecoregions, the Dinaric Western Balkans, it's the majority of the country, and the Greek Western Balkans, small part of some river courses in Usine and Rože municipality. Types of surface water bodies were established based on the description in Annex 2 of Water Framework. For rivers, the descriptors are altitude, catchment size, and bed composition, and there is 9 types for level 1 to level 9. For lakes, bed altitude, surface area, bed composition, and there is 5 types from L1 to L5. For mixed water, there is 5 different water bodies with the 4 types, and for total water, there is 5 water bodies with 2 types. In that up to ground picture, you can see the different types of water bodies in the different colors. Lakes and sea are also important for the water resources in Montenegro. Natural lakes in Montenegro are relatively numerous. There are many located in national parks. In addition to the larger thermal clouds going to the Geographical Lake, there are also many smaller lakes which are of glacial or karst origin. Another lake is the largest, and it's located in the lowland area of the southern part of the territory. Another lake is Shast Lake, second largest, and both of these lakes represent significant natural reservoirs for migratory birds and numerous species like fish, which along with the other large lakes and coastal flora and fauna illustrate the values of this area. Artificial lakes on river Čekotina, Zeta, and Grafovka are also very important for the hydrography of Montenegro. The Adriatic Sea is located between Montenegro and Italy. It's about 200 kilometers wide, and the total length of Montenegro coastline is about 300. About 80% of the coastline is rocky, where usually large water depths are found immediately off the coast, while the remaining part of the coastline is shallow with a sandy gravelly. Groundwater refers to all water that are below the surface of the ground in the satellite zone and is in direct connection with the soil of subsoil. The key aspect of concept of groundwater body is that it is a management unit in the terms of water framework directive necessary for dividing in intensive geographical areas of aquifers for effective management. This concept considers aquifers for significant water abstraction. These aquifers should be made to ensure suitable, balanced, and fair water use. Aquifers for its linkage to ecosystems. Some aquifers are inseparable from ecosystem and can be pose ecological risk of polluted or over abstracted, which may reduce base flow affecting surface water systems. The goal of characterizing groundwater bodies is to determine the quantity and chemical status of each water body. The water management sector is responsible for the care of water resources within water management and set frameworks and harmonized needs and demand of various forms of water use. The use of surface and groundwater must be in accordance with the law and is used for various purposes, including drinking, sanitary and technological needs, irrigation, bottling of mineral and natural waters, fish and shellfish farming, salt production, electricity generation, and other operational purposes, both tourism, navigation, ecological and other purposes in accordance with the law. Okay, goals of water management and developing in Montenegro. For water supply and quality, it's to ensure sufficient quantity of water with appropriate quality for public supply and economic activity without harming the environment. To reduce losses in public water supply system to below 30%. To protect water sources, conduct exploitation and converts water resources for current and future human consumption. Water use in the industry to promote rational use of water throughout all sectors to provide adequate water supply for industrial production and irrigation. Hydropower and ecosystem management. Rationally utilize hydroenergy potential while ensuring minimum flow and environmental flow to enabling passage of aquatic organisms in area affected by the hydrotherapy. Featuring aquatic ecosystem, continuously financing and modernizing the fisheries, preserve the water quality and maintaining the aquatic ecosystem alongside sustainable fishery development. For tourism and recreation development, to develop water tourism capacity along the coast, to promote river tourism and impulsive, to expand the total area of land. Water supply is very important usage of water resources. Quality standards of drinking water, food production, processing, and hygiene must meet prescribed quality standards. Approximately 90% of water for consumers comes from underground sources. Only 8% comes from surface water accumulation. Despite high precipitation in some areas, geological and other factors cause difficulties in providing regular water supply, especially during dry season. Urban water supply is generally good, but for the rural settlements, it's not so good, and they use mix of other water systems, private systems, and individual systems. We don't find construction of this. In the coast, there were improvements in water supply by regional water supply systems and it improved also water supply reducing water in the sun. The drinking water quality inspection. So for monitoring of water quality for drinking water quality is the responsibility of public health. They analyze the drinking water quality. The World Health Organization identifies drinking water quality as a key health indicator, highlighting its importance in public health protection. Drinking water used for consumption, for food preparation and hygiene must be available in sufficient quantity and to be free from toxic and substances, pathogenic microorganisms profiles. Sunset protection zones are largely established to safeguard drinking water sources. However, protection sources in karst and alluvial areas challenging, especially near large cities, due to threats from urbanization, industrial activity, agriculture, waste disposal, and wastewater pollution. All municipality water supply sources carry out disinfection. Special qualification treatment is supplied only for water from surface reservoirs. Get the water they are supplied for the reservoirs, not from the groundwater. Practically all settlements in Montenegro use karst spring water for public water supply, thus utilizing the resources that is very vulnerable to the climate change. This is case with the Riverine springs in exchange. Riverine spring setting, karst spring everything level, as well as number of spring sources in the coastal part. Increasingly pronounced climate change, which in the last decade has manifested through rising air temperature, prolonged dry period, uneven precipitation patterns, and the refining of fuel flow are leading to disturbances in stream flow, water source formation of torrential floods, and landslides. In a rear flow coastal path, prolonged drought period leads to disturbance in the equilibrium boundary zone between saline and fresh water, resulting in the salinization of water source. The reduction in annual snowfall, as predicted by IPCC scientists, can negatively impact water supply. Largely amount of snow in the catchment area of the sources allow the hydrological minimum of these peaks to occur later in September, compared to water sources whose catchment area is characterized by lower snow quantity. When the hydrological minimum occurs in the beginning of August, during the peak water consumption period. One source of water is also irrigation. In Montenegro, only 20% of arable water is irrigated. Irrigation in Montenegro is a growing area of interest, especially as climate patterns shift and agricultural developments become a more strategic economic field. type of irrigation, surface irrigation that is still in use but not efficient. Sprinkler and drip system, increasing especially in vineyards and high value crops like vineyards and peaches in Montevideo. Water sources are rivers and streams, groundwaters and reservoirs. Problem are financial barriers for farmers to adopt modern irrigation systems, but some EU funds and international aid programs like IPA are helping improving water management. Government is also promoting precision irrigation through subsidies and pilot programs. Fishing is also usage of water, and it includes both fishing and aquaculture. The country fishing waters are streams, rivers, lakes, and reservoirs, and these waters are valuable for their extensive networks, high quality fish species, and strong agricultural potential. Mountain streams with their cold, clear water and stable temperature are ideal for salmon farming. However, illegal fishing and industrial pollution can damage fish population and water quality, especially in rivers Zeta, Morača, Lim, and Tar. Mountain lakes with fish cover about 547 hectares, include lakes Flag, Crno, and Beogradsko, but low lake Skade dominates freshwater fish catch in Montenegro, counting about 96% of total, and have about 45 fish species, and they are mainly from 16 extent. Montenegro has several reservoirs like Krušac, Slano, Liberović, Grahova, Silo, and Dotilov, and they are stocked with salmonids for sport fishing and cake fish farming. There are several fruit found across Montenegro, mainly from California trout, supplying with both market fish and breeding stock fish for the stocklife. Trout farming in cages in Lake Skadar and in Piva Reservoir has also been very successful. Marine culture in Montenegro currently takes place only in the upper Bay of Kotor, and there is some plans to expand to the open sea. The cultivation focuses on white fish in floating sea cages, producing about 1,114 tons annually from the two farms. Shellfish farming, mussel and oysters are also limited, and there is 6 farms producing around 200 tons of mussel yield. This is regulated by law of marine fishing and marine culture, and they regulate also sports and recreational fishing, which requires a license and prohibits selling the catch. Fishing must be done by a patrol with the gear, and daily catch limits are set by the limit. Despite the significant potential of scarce spring water, also the number of sources lead to strict quality standards regarding their use for bottling the potable water. The commercial exploitation in bottling of quality spring water in Montenegro is just in the beginning, and the available capacity for bottled water production are not fully utilized. So currently in Montenegro, besides the mineral water factory Bjelaška Rada, there is 6 more water factories that are operating. That is water filter from spring Vukovička Vrela Krebaljevo, then Aqua Monster, spring Rokovica Voda Nikolo, water Aqua Bianca, spring Deda Vizio, also Polaška. Water Golska, spring Jerenija, water Dira, spring Gusareci from Sarnik, and water Gosia water, spring Gosia water that is from municipality sector. Also, there is one factory that will be operated soon. It's from Russia and water will be taken from the spring. Water supply for industry and energy for technological needs. Between 1978 and 1993, industry in mining, including thermal energy facilities, used 60 to 142 million cubic meters of water annually for food. Water source for region is public supply, private sources, underground and spring waters, and surface sources. Major industrial customers like Podgorica and iron works mixing have their own water system. That use water for rivers, also Podgorica, and groundwater, while iron works use water from the river in Podgorica and its part supply. The most of this water is recirculated. The food and beverage sector is the next large user with a brewery industrial business practice initiative, relying on this within its sector. Another use of water is bathing and recreation. Montenegro boasts unique terrestrial water features ideal for tourism, recreation, and sports, including mountains, beaches, rivers, deep canyons, Tara and Nevidio, Car Springs, and numerous lakes like Crno, Biografska, Savska, and Shader Lake. Also, reservoirs, lakes on Kriva Gratanica, Executive Visitors, also aid to the state stewardship. Despite rich natural resources and biodiversity, except for the few sites like Lake and Biografska Lake and Tara Canyon, tourism remains limited to the natural lovers and researchers, with only a 3% of the negative tourist accommodation in this area. Along the 300 kilometer coastline, there is about 70 kilometers search for swimming and sunbathing. And the quality of drinking water is examined on the around the 100 beaches along the coast, and it's done by the Institute of Biological Research in Portland. And since 2003, the best beaches have received the International Blue Fair Record Label for quality environmental standards. Hydroelectrical use of water. Montenegro's abundant surface water flow offers significant hydroelectrical potential, but only 70% of that has been harvested so far, mainly through two large plants, Caruthers and Kriva, and small hydropower plants. Since 2007, detailed hydrological measurements have been conducted on various water courses to assess feasibility for small hydropower plants capacity up to 10 megawatts. While these small hydropower plants contribute to renewable energy goals, they have faced criticism from environmental groups. Concerns include the impact on river ecosystems, fish mitigation, and local communities. In response to that, the Montenegrin government suspended the licensing of renewable small hydropower plants in 2021 and initiated the review of the existing legislation. Impact of small hydroelectric plants without the water forces include changes in river water quality in sectors, barriers to basic migration, disrupts of sediment in ocean, also the ecological flow and flood cycles, and the changes in water chemistry temperature. These effects lead to space displacement, habitat loss, and impact on terrestrial. Use of water for navigation. In Montenegro, inland navigation of rivers and lakes is minimal compared to outward. Navigation is mostly located on Lake Skadar and Lake Sivas, mainly for fishing and recreation of from local people. Most rivers, except the Bojana, are unsuitable for navigation due to gradients and shallow depth. The Bojana River navigation potential is limited because the river desert vegetation borders distance to Albania and Atlantic. Main maritime ports include the commercial ports of Bar, Marina Bar, Port of Kotor, and Bijela shipyard. Other local ports are Burgas, Divac, Port of Montenegro and Kalimat, Kotor, Ristan, Zelenik, and Kecinuk. Montenegro coast has two main navigable areas, the Bay of Kotor and the open sea from Cape Kotor to Albanian border. The Bay of Kotor is the largest natural harbor with two international ports, Kotor and Kecinuk. Marina and then Marina in Divac, and many small docks serving the tourist and fishing vessels. Also, traffic here is active. The port of Bar is the largest and the most important port, modern infrastructure and equipment, making this Montenegro a hub for international trade. Exploitation of river sediment. Montenegro rivers produce significant amounts of sediment annually, impacting river flow and flood rate. Extracting the sediments is beneficial when done sustainably without harming the ecological regime, bank stability, or ecosystem as regulated by the water law and management protection. However, illegal extraction of gravel and sand has caused major ecological, economic, and aesthetic damage, creating river devastation, unnatural landscapes, and river management. This has led to the moratorium of sediment exploitation, allowing removal of the river flow regulation process. Gravel extraction can negative effect on surface water by destroying benthic fauna, vital for the river ecosystem, and altering the riverbed morphology, affecting water flow. The Mora, Chatara, and Green rivers are faced with the high pressure from subsidence. Water ecosystem under special type of protection. Protection area is all water bodies intended for human use. Area designated for the protection of economically important aquatic plants and animal species. Water bodies or park or state intended for the recreation, including the areas designated for swimming. Areas flexible for air purification, sensitive to nitrates, and area designated for the protection of habitats in accordance with the Natura 2000 program. Identification of different types of freshwater water sources. Pollution sources include concentrated pollution sources that can be from urban wastewater, from industrial wastewater, and pollution from unstable landfill that dumps surface to groundwater. And different sources that include rural settlement because there is lack of centralized sewage system and they use the septic tanks for the electricity. Agriculture, runoff from agricultural land containing fertilizers, nitrates and phosphates, pesticide and animal waste. Forestry, where soil erosion and sediment runoff leads to disruption of natural hydrology, and traffic pollutants from road runoff and traffic maintenance facilities. Another pressure on the water quality is physical pressure that involves hydromorphological changes like dam for hydropower and water supply, river channeling for flood control and transport, and there is a case from Tara River in Polašin and the Lim River in Belan. water monitoring. It's in 2019, the first time when monitoring of surface groundwater was conducted according to the Water Framework Directive, based on the regulation and the method guidelines for determining of status of surface water and the groundwater. This requires a new approach in assessing water status, including the review of existing monitoring parameters, some new location for surface and groundwater, as well as new equipment. The novelty in this field is also the establishment of clear criteria for determining the ecological status of water bodies. The ecological status determined based on the result of general physical chemical elements of surface water bodies is classified into three categories. Very good status, when there are no changes in natural conditions or these changes are very small. Good indicate a slight deviation from reference conditions, and moderate status. It is proposed to adapt measures to achieve good status within the coming years. Water Framework Directive requires council to establish surveillance, operational, and institutional reporting. Monitoring that is aligned to the Water Framework requirements includes biological monitoring with the 5 biological quality elements, benthic invertebrata, phytoplankton, phytoplankton, microfish, and fish. Monitoring on general physical chemical parameters, accompanying biological monitoring, analysis of basic water quality parameters such as pH, value, temperature, oxygen level, alkalinity, salinity, and nutrients. Monitoring on hidden morphological elements, accompanying biological monitoring, its quantity and dynamic of water flow, connection with groundwater, river continuity, variation in river width and depth, structure and sediment of riverbed, structure of the riparian zone itself. Chemical monitoring includes monitoring on the 45 priority substances from the Water Framework Directive as defined in the Directive of Environmental Quality Standards. Identification on specific pollutants in river basin in Montenegro for the purpose of establishing of its own environmental quality standards and accompanying monitoring to assess ecological status. The order of monitoring and measurement are conducted by different meteorological service. Currently, there are 35 automatic meteorological stations from which data on water level and temperature is collected. Quality of surface waters in Montenegro in 2024. Monitoring was conducted by the Processing Institute from the Water Quality Department. The monitoring the network for surface water quality included 21 water courses with 30 locations. The good status was on 7 locations, moderate status on 18, bad status on 3, and very bad status on 2. There were also 3 natural lakes was examined, and they all have a moderate status. 5 artificial lakes, 3 of them were with good potential, 2 moderate potential. For mixed water, there were 5 locations, 3 with a good status and 2 with moderate status. And for coastal water, 5 locations, 4 for good status and 2 have moderate status. Quality of groundwater in Montenegro. 38 monitoring groundwater sites, 29 were boreholes, 3 of them were filled wells, and 6 springs. The examined parameter was physical chemical parameters and specific for pollutants pesticides. On 20 of them, the status was good, and 18 sites have a bad status. Among these monitoring stations, 8 of them host the network for monitoring in accordance with the Nitrate Directive. Water quality protection. Strategic goals in achieving and maintaining good status and good ecological potential of surface water and ground bodies in order to protect human health, preserve aquatic flora and fauna, and meet the needs of water users. Operational goals. Prevention of pollution of surface and groundwater, reduction of pollutants input from concentrated and diffuse pollution sources, reduction of pollution quantities reaching surface and groundwater from unregulated and unhygienic waste disposal sites, organizing water quality control and sources of pollution, prohibiting the lifting and the introduction of hazardous and harmful substances into water. Economic measures include paying the fee for water pollution, which is not lower than the cost of its purification. Establishment and use of protected area in accordance with the water plan. Protection from water. It's flood protection. Flood risk management refers to the strategies, practice, and tools used to reduce risk and impact of flooding on people, property, and the environment. It involves both preventing floods and reducing the damage they cause. Montenegro has developed flood hazard and flood risk maps with management plan for 2 river basins, in line with the EU flood directive. This includes identifying the flood-prone and erosive areas and constructing, maintaining, and managing water facilities. Also, flood-prone river valleys occupies a small part of Montenegro, but are socially and economically significant because they contain major settlements, including valuable agricultural land and close important station roads. Protection for harmful effects of water is developed flood protection system from external and internal water, ensure its efficient, coordinated flood defense, continuously monitor and focus hydrometeorological events, use water line and flood-prone areas appropriately, regulate water courses environmentally, maintain and control water courses and hydraulic process regularly, reserve water regime through target river sediment measurement, establish legal framework for erosion and flood protection, monitoring and maintain protection procedures consistently. And the last thing is financing in the water sector. It's very important. And sources of financing in the water sector is EU funds and international donation, domestic source of financing, and loans from foreign banks and international financial institutions. Domestic contribution on financing comes from different water fees. Fees for the use of water, fees for the protection of water from pollution, fees from extracted material from waterways, fees for adherence in water rights, fees from the lease of public water assets and the water facilities and system, donation and other sources in accordance with the law, and the application of the consensus law. Water fees are based on the quantity induced method of extracted, utilized, delivered, or treated water per liter of bottled or packaged water, based on the quantity of fish produced, based on the quantity of electricity produced, or based on the capacity of the facility. The funds from these fees belong to the budget of Montenegro and budget of municipalities in the ratio of 70% to 30% in the favor of the municipality. And like a conclusion, successful implementation of integrated water management requires collaboration among stakeholders, effective governance, equitable access to water, and adaptive strategies in response to climate change and growing demand. In a world facing increasing water scarcity, climate change and pollution growth, integrated water management is essential to ensure water security, protect ecosystems, and support sustainable development of present and future generations. Thank you for your attention.
Okay, are there any questions?
Yes, thanks a lot for the nice presentation and the overview. I was wondering, you say that 92% of the water comes from groundwater?
Yes,
And
for
you-
the public supply, for the drinking water resource.
Yeah, and you say that you just recently in 2019 started monitoring.
Uh,
Um,
No, it's the monitoring of surface, quality of surface water is done by the Hydrometeorological Institute. And the monitoring of drinking water is done by Institute of Public Health, and it's regularly for a long period of time.
But it also, I mean, the monitoring also include water
Monitoring of
levels,
ground. What?
right? It also include water levels. So groundwater
Yes.
levels.
Yes.
So I was wondering if you can say anything, if there is anything significantly changing in the groundwater levels since 2019, or do we have any measurements that range further back?
Monitoring of groundwater started in 2019. And the level of, there is some automatic, not automatic station, but contact. It waterfall, and I measure the water level and temperature. And I'm not sure if something changed from that period till now. I'm in the other part of water quality, not for the quantity of water, but there is some. I'm not sure that there is some differences between that period and now.
Would be interesting to know, given the large quantity of water or the percentage of water that's used for groundwater. Yeah, thanks.
Thank you, Christoph. Thank you for the nice presentation. I had just one more question regarding the fact that you say that there is a lot of municipalities that are populated by spring waters that are used like Škurda or other springs that you mentioned. What would be, and on the other side, you have the climate change impact and it's somehow not really aligned. What would be your suggestion or how this can be solved or debated? Okay.
Coastal municipality are supplied with water from regional regional water supply, and there is enough water in that period during the summer. And some that brings in the coastal line is affected with the salinization in some period. And it's the problem of that mix with the spring water and with the saline water.
whether my family will whether I'm so if consider climate being for needs to be touched or things, we be aware of that there are movements for prostitute are very good days and times yet. So there are many actions like else. So it's very good for some 2 hours. We get 3 or 5 days more difficult and more than 40 days possible to solve currently process of current business models. More than that are just protections. More statistic out there. It's about breaking down or how foreign customer or production it's more of it's easy for us to say that, for example, in Podgorica, there is more temperature with high values summer, but it's impossible to say different what will be. So there are too many limitations making forecasting projections of relevant time. And every of those limitations starts from these graphs that we can see many processes which are for example scale about few centimeters, time scale about few up to in some scales global inflation, which can be too many hours for years, decades, and too many days. So from the turbulence cascade, turbulence production, thermal, tornado, planet force, lot of heat, which are the processes of yours day on up to 1 day and few kilometers space up to hurricanes and systems, front cyclones, broadly based on global inflation. Every of those processes affect each other, and there is a complete necessity that all learning occurrence of weather or climate. So starting modeling the first system model, global climate models, that know that there are too many systems that will be around from the cryosphere, polarized depths, the ice, permafrost, it will cover around the wetlands, the land, hydrosphere, oceans, lakes, and rivers, biosphere, ecosystem, and atmosphere, air, every of those components. Some, let's say, stable and accurate model which can forecast for main protection. Much more than this. So there are, or we start the story about models, about population model, about climate model, future climate model. There are top 10 climate years, let's say, some applied climate models which are used by the global leaders companies from different kind of industries like Google, IBM, and so on in order to make prediction in order to have some let's say about the urban climate modeling, not climate models, ocean modeling framework, carbon footprint modeling, modeling, natural modeling, every one of those frameworks those some role climate or global climate models set directions and after downscaling and bias correction possible to further calculate some apply, let's say apply use to how there we have the types of climate models all we can classify models that for example big components are or guides or some simplified or so let's respect modeling start from models. So for example, kind of that model balance model, which is highly simplified, average variables for large regions, and they trust to processes. There are some medium models which can be or model intermediate or things are which are that will depend on the inflation model, global climate model. That model was complex, supply of this model framework that so also there are some other classification. For example, we can divide the spherical circulation model, ocean circulation model, atmosphere ocean circulation model, and Cooper general model. So for the lines, we are going to talk about general circulation model and how those models use laws and equations to model climate variables. So our questions are for computers. There basically a area of models for saying or all. There are observations based on quality of observation. So we are expecting them for model development of how biological principles and laws. We have to take care of it. And of course, American Revolution and American equations, something that we have to have in order to calculate every brain cell birth system, those equations, and make some forcing and taking into account boundary conditions which are not included in the model or observations. And after simulation was done, there then we can, based on the results, test of the validity of the model and make some analysis of projections. So there are few difference and huge amount of natural resources and climate model. So the basic equations for atmospheric flows are from the principle of correlation of mass, momentum, energy, and of course the correlation flows are the rate, see the rate of change, mass, momentum, energy, because since the mathematical prediction or forecast weather few days get, we can assume that there are no changes mass or momentum that will not for climate projections. So in atmospheric science or climate prediction, it's not common to have 7 equations with seven variables which need to be calculated every itself. So the base there is no problem. So you have to calculate by or set the 7 equations with 7 unknown variables, 3 components of velocity, pressure, temperature, and specific humidity, and the density. Before these equations are used in models, some other approximations have to be performed. For instance, assuming hydrostatic equilibrium, which is a good approximation at the scale of global outside models processes. Those approximation provides a considerable application of the equation of motion along the vertical. Secondly, we have to use some other type of approximation like quasi-approximation, and of course we have to use some other equations which are connected with clouds and water different things in them. So every climate model requires some input data to run it. Besides the observations, there are some inputs which are also it's good to know who that accuracy of for this it's very different place topography, line, and bathymetry also properties, land, soils, shape of the land, background of bed of the roughness, some dynamic properties, soil like matter, soil structure, bulk density, water, and water capacity. Boundary conditions for all subsystems, not necessarily desperate model. So distribution of vegetation, complex topography, light sheet, forest lines, land cover, homogeneity both taking both models. There are also important to take solar forcing, that means monthly or solar and solar radiance. Also emissions, monthly or annual graded CO2 emissions and concentration of greenhouse gases and aerosols, global mean time series of black carbon, organic carbon, and so on. Also, we have to take into account volcanic forcing, dust, water and water vapor and carbon dioxide. Also, ozone is a very important component of the Earth system, energy budget, so on. So, time of all anticipation for forcing the models that do not include interacting chemistry. Important. On this slide or on this graph, we have the simplified representation of what's going on in simple energy balance model, where we just take how solar radiation is absorbed or reflected or transmitted atmosphere and by Earth's length, and how all of those processes can affect Earth energy balance. So there are not always aerosols, clouds, ozone, and greenhouse gases, and large aerosols, which they're interacting with short wave, as short wave sun radiation, as well as long wave radiation, radiation from the Earth. There is also present some latent and sensitive impulses and state of the vegetation, ice or snow cover, and ocean color and wave. We are going to a more complex scheme or graph which going to represent the actual processes, the processes in ocean and atmosphere. In the three, the most complex global circulation model. So those kind of models include the atmosphere, land, ocean, sides, and biosphere. And it starts with incoming solar energy, solar radiation. And there are too many processes in just atmosphere and clouds which affect those radiation. Also different let's say temperature over the surface due to the lot of factors cause the wind, and wind also affect the ocean streams, waves, and so on, which again affect the upper and lower layers oceans. After that, there are too many exchange heat between ocean and atmosphere, which again make whole system or model conform. So for climate models, there is a very long need for simulation, and because of the importance of having the right climate projections, we have to make models in that way that the calculation will take much less time than the real time of your outside. So for in order to achieve that, we have to make some really great approximation, calculation, grid space and so on. So we have to do parameterization climate models. Parameterization is necessary because it replaces small scale or complex processes with simplified equations. It is necessary due to the computational limits and process complexity. Examples of parameterized processes, actually every process which are in the smaller scale than actual grid size in climate model have to be parameterized. So turbulence, flow, pressure, radius, transfer rate of carrier, all of those processes have to be parameterized. Steps of parameterization are to ignore minor processes, simplify using subfunctions, and apply statistical and empirical relationships. So the importance for climate models of parameterization is that parameterization enables enforcement of key effects without human data, essential for accurate simulation of atmospheric oceans, high resolution oceans models, and coupling with other systems further improve reality. So that's for now presentation. For already mentioned global climate models, resolution in climate modeling are next. Resolution or size of grid cells are 100 kilometers per side or more. Higher resolution is more detailed, much greater computing power. So resolution improved from 500 kilometers in 1990s to 16 kilometers in models. Also, vertical resolution is important. Early models used to have just few layers. Recent models using up layers in atmosphere. Temporal resolution have to let's say take into account the time step size of step size in which equations are calculated for as well as numerical prediction. Also in climate models, there is some conditions which have been fulfilled in order to successfully make calculations of climate models. So Frederick Curran-Levy criterion actually limited us with minutes and kilometers temporal and spatial values. So time step size doesn't mean that the model results will be that time resolution, because there is also need to have much more output size of those files in order to space. Computational demand, higher resolution greatly increases calculations. What model out then for global climate models or are most effective tools are the tools here. Climate modeling has a large number of variables for over the whole globe and for supply. We also have to or start, or it has to be some protection that possible, some local weather forecast or climate protection. It goes atmosphere, atmosphere, earth system, everything, all, or we can get the wide range whatever. Models, common models are depending on type of forcing or patterns. There would be from about or whatever from planning that but if it's like take one to 3 points over this means that we deal with results from global models, spatial resolution of 10 or 50 meters, and their breakpoint over Podgorica. That's not a representation of that values. That but as a values over the box. Or so, well, there are a lot of limitations of climate models which are unavoidable for really some no testing quality of weather predictions that few hours. So from the beginning of the data observations, there are master data sets for course or so models so might because of possible scenarios for climate. There is no best model or example both people person they so compare the results from climate models predictions. They some bias and correction techniques. Make some influence for success results in the future phase, roles or lows or concluded based operation or that models and real events some confidence. Not but we can put the real world developed model project not that's right. So but even scenario of someone, let's say, green house, let's say, can be the same as we assumed that starting time to the simulation that doesn't and expected climate projections. But so there are also one are really great models is process feedbacks. For example, time of work guidance, mountain ledgers are post model. Also, we don't know when some volcanic eruptions are going to do it, and how does volcanic eruption will affect climate and how that will affect whole Earth. So also increase complexity a lot, but not the models better. Most climate models have resolutions of the order of 1 or more. For that, the outcome presents one value of variables parameters for the consumer. Whereas there could be human that we could use there. So there is 100 times 100 base box just one value method. There are so many ways for getting a lot of patients that helps imperfect activity for our knowledge, like limited for all something together and more than ability. Also, there is the one being how affect climate on the Earth, how for source of life, but source of for transport numbers are very some projections. How sometimes affect the financial real ocean stream in charge for the transport from also there are well-known oscillations, but very so have some for us it's how much or further known oscillation of planning and that part of the air globally, but this not oscillation for us. There are some future low pressure Iceland, the strong or high cyclone in the northern island, and different seas go scale systems will update the weather across the north part of across the part of the North America and Europe. So that we put not the practical place that means Iceland depression cycle high pressure system very strong, big press and high, so that's the one. That's very general problem. That's the better one. Very important part of America. That's what we call there are four CIs on the south central part of east part. They will affect by war here. Also, that time Europe expect more weather. They are not, but poor and the right weather and good dry weather and south part. So this is just one example that we can based on some let's say signals from the huge from huge scale systems know which type of weather can expect us in the part of the world, and that is something that can be from the point of climate models. Climate models maybe for extended forecast be better to catch those peaks. Also, I already mentioned that we don't know when volcanic eruption will occur in future, and volcanic eruption affect the weather and climate at all in different scales in time and space due to a lot of ash and different gases which are going to the higher layer atmosphere because we know that the main weather occurs in the troposphere, but when volcanic eruption occurs, a lot of water vapor, different gases, ash, so on, will reach the stratosphere and upper layers of atmosphere, which is uncommon and which can affect a lot of processes on the Earth due to the reflection, absorption, and influence on the sun radiation chemistry, upper layer of atmosphere, and how everything of that is all together it's presented. So also we have to know that there are in atmosphere two types of aerosol, which dealing with sun radiation different ways. We have scattering aerosols, which just reflect the sun radiation and don't change the length or wavelength of sun radiation. And also we have the warming aerosols, which absorb radiation and affect the atmosphere that way that there is what aerosols scatter solar radiation, less solar radiation, which leads to ultraviolet cooling. And the atmospheric circulation of these processes spread and cooling radical is vertical. So aerosols absorb solar radiation. This is the aerosol layer, but surface which receives less solar radiation. Then cool locally. That is the example when we have the warmer, higher layer in atmosphere than other one surface. And at the larger scale, there is a net warming of the surface and atmosphere because of circulation a mixing process, redistributed energy. Those kind of aerosols, source for those kind of aerosols may be from the organic eruption to the greenhouse gases. So regional climate models, they purpose of regional climate models is that they provide climate projections at regional and national levels for better policy making. Important regional processes, mountains, dust, etc., can impact global climate. Nested model approach, regional climate models are embedded between global climate models and each cycle. So there is constantly conversation, or let's say original climate model and global climate model to be exchanging information on boundary or lateral. Global climate models provides large scale context, while regional climate models are higher resolution for downscaling. Downscaling is more for us involved that it has its local climate projections, especially in complex regions like mountains and forests, which we think of there is different classification of how global climate model on enforce green can be used from the original climate models, which has a limited area model domain. Also, there is a lot of physical processes which occur in the atmosphere and the ocean, which are different regional and global climate models. If the grid space in regional climate models is much better or much smaller than the global one, there are some processes which don't need to be parameterized, but those kind of processes calculate the regional climate models. So, yeah, now going to talk about climate scenarios. Climate scenarios are not made of scientifically grounded possibilities of what the climate could look like depending on the range of factors. These include human activities such as deforestation, greenhouse gas. By adjusting these variables in the climate models, scientists provide various different and assess the potential outcomes for actions or inactions. The purpose of climate scenarios is to help governments, industries, to plan for and potential for climate. So these scenarios allow decision makers to identify risks, guiding efforts in climate mitigation. The most common climate scenario is representative pathways. The representative pathways are a set of climate scenarios developed by scientists to explore different possible futures based on varying levels of greenhouse gas emissions. These pathways are named after the level of radiant forces before we get them. They project for the year 2100, method was that the RCP scenarios are one of the policy to assess the range of potential outcomes and guide for prevent consequences of climate change. So there are different kinds of RCP scenarios. RCP 2.6 is the most optimistic scenario, aiming to limit global warming below 2 development. It assumes that aggressive methods are taken to reduce emissions rapidly, with CO2 emissions peaking in 2020s and declining sharply afterward. RCP 4.5 gives a median scenario around 2040 and then decline, leading to moderate global warming for around 2.5 in the RCP 6 is another intermediate pathway. RCP 6.0 perfect scenario variations. Bit later around the 28 and result global warming of about 3 degrees by the end of the period. RCP 8.5 often refer as business as usual or worst case scenario. RCP 8.5 about this pathway could result in over 4 degrees Celsius from global warming by the end of the projection period, with several and widespread effects on ecosystem, sea levels, and weather patterns. So key types of climate scenarios is another key type of climate scenario are shared social waves. The shared social waves are add an additional layer to climate scenario modeling by incorporating human development factors such as growth and conservation, societal shifts. These pathways consider how global socioeconomic trends will influence greenhouse gas emissions and climate change. Together, the RCPs and SSPs provide a comprehensive framework for exploring different futures, helping policymakers and scientists understand the broad range of possibilities based on human actions and policy. So there are 5 FSPIs pathways. So FSP1 is the possibility scenario. This scenario identifies for where society shifts towards stability, to focus on well-being, equity, and environmental conservation. Emissions are drastically reduced, aligning with the goal of RCP 2.6. SSP2 is middle of the road. The scenario development follows historical trends with moderate progress towards stability and uneven global development. This pathway aligns with RCP 4.5. SSP3 scenario envisions a fragmented world where countries focus on national interest. Economic growth is uneven, and global cooperation on climate action leading to high emissions. This scenario is aligned with RCP7. SSP4 inequality. This scenario highlights that inequality between and within countries. While the global elite drives technological innovation, a significant portion of the world faces slow economic growth and limited access to resources. Emissions can vary widely, but tend to align with RCPs. SSP5, fossil fuel development, pathways society, which use rapid economic growth and high fossil fuels, but over time, align with RCP. So there are also indications and uncertainty climate scenarios. First, main one is and models across the interior of Earth's climate scenarios of the scenario of another vector. This relates to the fact that control by ultimately natural variability. These are certain climate And downscaling techniques allow global models Oh, yeah. Global common model projects are from this greenhouse aerosol for second part work going by to it is rating model projects are found on current model and third probably is starting with model projects starting with so what are regional common models? Regional common models are models that common they provide us by boundary condition of models was friends. The common is that global common one of professions have one output, one result, and from regional common model run by boundary of that one over model that results from those different. This is used for many approximation application other are very global. For very interesting global different models are for evolution global kind of model from 100 while the rating kind of models relatively of them. So honestly, it's higher than output working. Global common model kept global for the while the original common they have a little over the global climate models found that we found that by global climate models have limited sources and part simulation. Global climate models have lots of computation and local limits, while the regional climate models have regional processes and they are global climate models for example. So go over the one some processes, atmosphere, ocean, other components of the Earth system, which are in spatial scale bigger than great scale of the model. We solve that specific, while those processes global common so the process models are very dynamics, radiation products and transfer powerful left actions surface energy for cycles and turbulence and boundary by process. So spherical surface interactions represented by these surface let's see the contrast and human heat island effects. And we have these like mechanism surface function. Spatial models are about spatial of 10 kilometers. In vertical, we have 50 storage levels on vector irrigation for processing and higher resolution depth of time steps for calculation of equations from minutes to hours, but the output frequency, that is the frequency. So what we say the output is daily or monthly, and long-term simulations can take this models. Key components, the parameterizations, original climate models are collection parameterization schemes, cloud physics applications, land surface model components, planetary boundary layer schemes, radiation transfer calculations, and the subgrid scale process. Oh, that graph have visual representation of all those processes that would be parameterized in order to efficiently calculate different vectors. This is the example of widely used open source community NOAA multi-parameterization options. This land surface, let's say, model is designed for applications ranging from upper land surface protocol ethical hydrological processes to coupled numerical error prediction and technical global or regional power simulations. It has been used in many coupled weather, climate, and hydrology models. So it's showing us that those part of some radiation remains in Earth system is equal to sensitive, latent, and ground oxygen. So climate uncertainties and challenges are next. There are lots of model structural parameter initial conditions because there are a lot of problems in classical weather prediction based on the initial condition rate. We have, for example, for the forecasting the weather in 3 or 5 days ahead, if we have unstable state of the atmosphere local region, there are very small shifting in the initial conditions can cause really completely different weather quantities for 3 up to 5 days forecast. So this is really great problem in climate protection much more than classical approach because the small errors from the initial conditions can cause much more errors later on every next step until the final result. Boundary condition errors, regional climate models, and scale interactions and complexities, computational limitations, and approximations. Mathematical foundation for define the climate models, regional climate models. There are some well-known equations, basic primitive, learning both processes. Those are Navier-Stokes equations for fluid motion, thermodynamic equations for energy, for mass rotation, hydrostatic anticipation, pressure, primitive equation system, and numerical methods for solving equations. Also, as we already mentioned, and the original climate models can have some scenarios, questions. There are SSPs, RCPs, and regional impacts vary significantly from the scenario by scenario. Because changing each of our boundary conditions are much more they affect the results much more in regional than global outcomes. Local climate impacts with regional climate model results, we can analyze temperature extremes, precipitation patterns, density, growth, flood risk, extreme weather events, and also, there are bias correction methods. It's something that is necessary if we want to be much better and accurate projection of the future climate state. So, bias correction methods. There are one delta method for simple bias correction. Linear scale bias correction technique can be applied on stochastic and non-stochastic climate variables to minimize deviations in the predicted and observed time series of past and future time series. This method requires that the time series can be grouped by the Montevitis. Also, there are types of using of the studies of monthly is a powerful technique. Technique for correcting biases in projection models by aligning the observed quantity with the model preference. This method is widely used in climate models. What makes quantum mapping particularly effective is the simplicity and additional efficiency compared to other bias correction methods. And there are multivariate bias correction approach. So multivariate bias correction is designed to deal with distribution and auto and cross-dependence biases in multivariate time series. Those time series are taken into variables over time. At the multiple time steps, it provides the flexibility of applying a simple single time scale for invariant bias correction to comprehensive multivariate time scale bias correction that is output in the requirement of So there are also traditional downscaling methods in order to have a better representation of climate model results over wanted region. There are some common and well-known downscaling techniques which can be divided in two groups: in dynamical and statistical downscaling techniques. Dynamical downscaling techniques are high resolution whatever how much the model simulation and this training approach. They are those dynamic models that are statistical downscaling relies on relationship scales. These those kind of are excellent and perhaps lies in last few years there are like great boom machine learning neural networks machine learning, especially algorithms, those algorithms applied code climate science. The digital downscaling can be replaced by much more accurate and much better and help and different approaches to downscale in traditionally tree grade model houses. So machine learning and deep learning applications models are in the process of drastically they are the implementation drastically increasing years. So there are those type of models we can use neural networks for neural networks dependent adversarial networks, they for super resolution of making different expected and further computation that condition networks the main good thing from ML and deep. So machine learning can be used by the regional models, and on that slide we can see how Australian group of scientists apply machine learning in order to make downscaling over the complex theory of RCM output. So an RCM regulator can effectively downscale global climate models using time code, and this method presents an affordable way to support resilience in the planning. So what are the agents of RCM regulator? The RCM regulator can produce similar results to a standard RCM, but is faster and more cost effective. Many global climate models can be downscaled with same sources, produces a far larger sample of climate projections, namely probabilities of increase be provided greater than the best estimate, provides a better assessment of uncertainties in projected changes, a better understanding of help support better decision making for resilience planning, can be used to develop RCM regulators. For example, for parts of the plane or different cost-effective methods which enables the assessment of climate change are the most controlled region scenarios and the production of climate information for smaller teams. And can also be used to fill in gaps in the regional climate model simulations in the coordinated regional downscale experiment, so-called Corvex framework. So on the graph on the right hand side, we can see that from the global climate models as input and planned surface properties, the field of machine learning model, we can downscale outputs in much cheaper and efficient way than traditional. So there are also advanced post-processing techniques in regional climate modeling. Example, averaging and weighting. And multimodal combinations, association method, probabilistic projections, extreme values analysis, and climate indices and indicators. So climate ensemble averaging was combining with outputs of multiple climate models to create more robust and reliable forecasts. Weighting is a method used to adjust the importance of each model's contribution, potentially improving accuracy and reducing certain effects. Uncertainty quantification in climate models involves defining and characterizing different sources of uncertainty that can impact model prediction. These methods aim to improve the reliability of climate projections by acknowledging the range of possible outcomes. Extreme value analysis that is a statistical technique and that is used in climate modeling to understand and predict the likelihood and impact of extreme events. It helps characterize the risks of natural hazards and ensures structure can withstand such event. Extreme value analysis or considers factors like the return period and return levels. It's defined the operational platforms of assets. However, works for maxima, this method focuses on the highest values specific time blocks of data, peak coverage threshold. This approach examines values exceeding the defined threshold, providing data on extreme events. And also there are applications in climate modeling where EVA can help estimate frequency, magnitude, expression, temperature, taking of the context of climate change. Also, there are climate indices, and they are simple quantities that characterize aspects of climate system, like incremental variability, extreme events, patterns. Climate indicators, on the other hand, are variables that represent broader phenomena and are often used to track climate change impacts, like sea level rise or greenhouse gas. For the future directions, there are certainly will make some couple of modeling, improve organizations, make some higher resolution simulations, also implement more prevention, make some advanced quantification techniques, of course, real-time climate monitoring systems. So, conclusion and summary is that regional climate models are crucial for regional climate understanding, but we use raw outputs with great possibility to make wrong predictions because we have to make really good post-processing of raw outputs from regional climate models to implement some bias correction techniques and to make variable downscale. Create global models and local facts that are seen in improvements revolution. Over the products, facilitating quantification still today, even there are a lot of companies like NVIDIA, Google, etc., which trying make accurate climate prediction. Still, we have something and also essential for climate adaptation planning are bias corrector and well downscale gamma so some project which is covered by each of European its destiny Earth. Destination Earth is the flagship initiative of the European position to develop a highly accurate model of digital model of the Earth, digital twin of the Earth, to model, monitor, and simulate natural phenomena, hazards, and related activities. These groundbreaking papers assist users in designing accurate and technical adaptation strategies, mitigation methods. Destiny unlocks the potential of digital modeling of the Earth system at a level that represents a real breakthrough in security, local, lethal access for information. And by pushing the limits of computing summer science, destiny is an essential pillar of the European Commission's effort towards the Green Deal strategy. So the idea behind that is over the global scale on 1 kilometer green space evolution. Destiny is fed by real-world observations, and these digital feeds can help us to better understand what has happened on Earth and what will happen ahead. Also, for students and other are interested the easiest way to access great and let's say huge amount of data sets which are certified while again license is open. Is a climate data store. You can make account and easy with the platform tools both data set and with some API requests make those data sets suitable for your needs. And also there are tools for quite effective Earthgate data and quality, which also communicate with data sets from the data store in way it's give us the much easier way of access, reorganized, quickly visualized, daily climate. Thanks.
Okay, thank you. Are there any questions? Thank you, Alexander. We are finished this summer school with a presentation from Sanja Radonjic, Wine in a Changing Climate, Winemaker's Perspective. Sanja, can you hear us?
Yes, can you hear me?
Yes, yes.
Oh, excellent, excellent. Okay, I'm so happy that the connection is working because I was a little bit afraid with connection here from China. So I am online a few hours ago and it worked very well. So I hope that until I finish the presentation, it will be everything okay. So shall I share the presentation?
Yes, please.
Mhm. Okay, here it is. Okay, do you see presentation? Okay, just please confirm me if you see the first slide. I guess that everything is fine. Do you see the slide? I'm sorry, can you just tell me, do you see the slide? Do you hear me?
I was muted. Sorry. Yes, we are seeing your slides.
Okay, thank you very
Okay,
much.
thank you.
Okay. First of all, I would like to thank all of you for contribution to this summer school, and I'm very honored to be the participant as well. I will do my best to explain as simple as possible from the winemaker's point of view the interaction between wine and the climate change and why it is important. When you look at this agenda, maybe it looks a little bit, how to say, comprehensive, but don't be afraid. It is like 8 chapters, but everything is continuous, and I guess that probably the part of these topics you already heard. First of all, I will present why it is important from the winemaker's view to monitor and to adapt to the climate change, which are the climate variables and how they impact on the grape composition and after all on the wine composition. Because me as an enologist, what is important to know for all of you that the wine is born in the vineyard. So we cannot have any how to say, desirable compound in the wine if we do not have that compound in the grape or precursor of that compound in the grape. So the quality of the grape is the first fact and the most important fact in order to make the top quality wines. Therefore, how it affects on the yield and grape quality, how climate change affect the wine composition and sensory changes, which are the most important for the market decision, for the wine consumers, how it changes also aromas and consumer perception as well. And after all, I will tell, but not too much on the vineyard adaptation strategies for the winemaker points of view, and what we can do in the winemaking technologies, what is possible to do to adapt and to take the best from the grapes that we got in these how to say tough agroecological conditions, which every year are much more tougher and tougher, and what are the key challenges for the winemaker in this situation. So when you work in the winery, or when you imagine that you have one winery, what is the most important thing is that you have the return on investment. That means that your production is sustainable. The first variable, the key driver, in not just in viticulture but also in the agriculture, is the yield. So you need continuous yield every year to make enough wine or whatever in agriculture, to have continuous quality as well. Every year it is one of the most important things to obtain. There is also the quality of the grape and wine, which is influenced by the climate variables every year. And besides that, when you have the good yield, so you have to process the primary raw material. When you have the quality, it is important to build the reputation during all over the years, and it should be constant. So you cannot, for example, we had some really tough years with low yield, and therefore you have to think further to how to deal with these years when you do not have enough quantity of the grapes. for the wine and grape production, what is also the most important, that where the place where is the where are the grapes are growing is the place where the wine is born. Therefore, in order to have good quality, top quality wines, it is important to have your own grapes. In winemaking and viticulture, it is one of the, how to say, premises that you do it in the one place. Buying grapes from other countries, how to say, damage the reputation. You cannot tell that, I mean, you can say that you are a winemaker if you buy the grapes from another country, but the story about the winemaking is the story, first of all, about the terroir. Terroir is the concept of the soil, sky, grape variety, but we cannot exclude the human influence, which is after all the most important and which drives all of this. So therefore we have the impact of climate change is twofold. First of all, the stability of yield. For example, in Montenegrin winemaking sector, this yield is not stabilized, last for 5 years at least. So the yield stability is really, really important, and grape growers surfacing with a lot of diseases in the vineyard. They have a lot of challenges to deal with the protection in the vineyard due to a lot of rains during the spring and so on. And after all, beside the yield, they influence the grape and wine quality. Which are the key climate variables that influence the wine composition, and also, I mean, first of all, the grape composition. You know, I guess that all of you know this, are the temperature, rainfalls, solar radiation, and CO2 concentration as well. It is already known that rising temperature, for example, if global warming exceeds more than 2 degrees of Celsius by the end of this century, it is, how to say, predicted that up of the 90% of current traditional grape growing regions, for example, I will take the Europe, of Southern Europe, like Spanish wines, Italian wines, Greek wines. Over there, they probably will not be able to grow economically sustainable, high quality wines, and to grow grapes and make wines. It is the mostly affected by the excessive drought during the summer and more frequent heat waves which occurs during the summer. Also, at the same time, higher temperatures for some countries, for the northern countries, can improve suitability for the production of grapes and wines. It includes northern France and potentially new wine regions such as Belgium, Netherlands, and Denmark. Speaking about the Montenegrin grape growing and winemaking sector, 50 years ago, I mean 50, not 50, it is I think 55 years ago, we had only 2 regions detected for the grape growing, which are very suitable for the grape growing and winemaking, and it was the Montenegrin coastal wine region and Montenegrin Skadar Lake wine region. And after 50 years, in 2017, the new zoning of the best grape growing regions in Montenegro was also performed, and therefore it was detected the 4 regions. So 2 old ones, Montenegrin Skadar Lake Basin wine region and the coastal wine region. But due to these climate changes, new grape growing regions are born, like the Nudo. It is very special microclimate, micro locality with very special climate conditions, and the northern part of Montenegro, like Nikšićko polje and so on. So how climate change, which contains the high temperatures, water deficit, and so on, influence the wine performance? So water deficit is the consequence not only the high temperatures, but also the very fast and rising evapotranspiration from the grapes. So how to say, during that time, the grape berries becomes very, very small. You know, grape vines and plant is like the human being, you know, like when we are sweating during the high temperatures, we have also the same situation with the grapes during these heat waves. We have the transpiration and how to say, we have the extraction of the water from so we have the concentration of total soluble material in the grapes. So evapotranspiration is the consequence. Speaking about the rainfall patterns, they vary too much and it depends by the region and by the season. For example, in sub-region Podgorica, we have around 700 millimeters annually, but it depends when the time when we have the rainfall. So it is the best to have some rainfall before the I mean, in the beginning of summer or sometimes during the summer, but before the grape ripening, before the veraison. But we usually have a long periods without rain, and then, for example, in 1 or 2 days we have a heavy rain. For example, we have a lot of rainy days in spring when it is very tough to grow grapes. You don't have enough time to do grape protection. You cannot have enough time, free time without the rain to do protection, to protect the grapevine from the most important diseases, mildew diseases. And sometimes these rains occur in September, the time before you have to harvest. And if you have sensitive grape varieties like the Vranac, which has very thick skin, this rain can really damage the yield and also the grape quality. What is also important that during the raised temperature, we have a compressed vine cycle, which that means that usually the phenology start earlier and the grape harvest start earlier. So this water stress may intensify and make the harvest faster, the time for the harvest to become faster due to this compressed vine cycle. So what we actually, speaking about the yield and wine physiology, what we actually have, we have small yield to the smaller berry size, but we also have lower bud fertility. The fertility of the grape wine is forming in this year for the next year. So due to the agroecological conditions and the climate condition in this year, we have the formation of the new fertility for the next year. And the consequence is that all wine growing regions will probably face the reduced yields because this severity will mostly vary according to the region and the seasons. When we speak about the impact on wine quality, it is known that moderate water deficits sometimes in some regions and in some vintages can enhance the red wine quality. But in the countries, it was likely before, for example, in Bordeaux in 2005. And we also have in 2011, almost 100 days without the rain. And it was in that time for the red wine, one of the golden vintages, one of the best vintages. But over the year, excessive water stress, which is common for the Mediterranean countries and dry climates, can also influence the photosynthesis of the grapevine. It can cause the leaf necrosis, and it can reduce the grape quality for the grapevine which are grown on very pure soil. So speaking about the grape composition, how the rising temperature influence. It is known that even small increases in average daily annually temperature can significantly influence the wine style and sensory profile. Wine style and sensory profile is, at the end, the most important thing on what we have to pay attention. When, from the winemaker's point of view, we need to determine before the grape harvest what kind of the wine style we want to make. And the sensory profile is usually demanded by the market. So market drives the kind of the wines that we need to make year from year. So the first thing that occurs in grapes is loss of acidity. So we have faster ripening of the grapes, and therefore we have less time sometimes to accumulate organic acid. What this gives after to the wine? We have flat wines which are not freshing, which are not crispy, wines which are not desirable. It is especially important for the white wines to have natural acidity inside. And therefore winemakers has to think how to surface with this challenge. And usually during the winemaking, tartaric acid is added according to the law, how much is, how to say, possible to add to the grape must and the wine. But this tartaric acid, which is added, makes wine much more heavier and not easy drinkable. And for white wines, this natural acidity, if it exists in the wine, it gives to the wine longevity. It can more time, it will be more time in its optimal shape for drinking. And you know, I don't know if you drink white wine, and when you taste it, you can usually, how to say, detect the difference when this acidity is corrected or not. When it is not corrected, for the white wines from the north countries, for example, they're usually lighter, easy to drink, has nice freshness. But if it is added, it makes the wine much more heavier and not easy drinkable. What is also the consequence and also the problem is the higher alcohol levels. High alcohol level is the consequence of the more sugar accumulation in the grape. And at the end, what do we have in the wine? Wine is usually much more bolder, also heavier, and it has the hot burning sensation in the mouth. The market and the people, not only now, but also before, don't want the wines which burn their mouth. They want balanced wines which are smooth, which has the structure that can handle with that alcohol content. After all, the aromas in the grapes, the precursors for aromas in the grapes are modified, like thiols, esters, and wine, after all, can lose flower notes, fruity notes, and also can develop some jammy character, like the wine is cooked like the plum jam from the plums, and it can develop overripe aromas. And it is known that, for example, the trend, monitoring the market of wine drinkers, wine lovers, and wine consumers, the trend is going in a good way for the lighter wines, for the more fruity wines, but the fresh fruits, not overripe or not cooked fruits. So let's see from one research, for example, we can see here the change from the most important parameters for the wine, which is potential alcohol, total acidity, and pH value. So from 1990 up to 2020, the alcohol rised for 2% of volume. The acidity drops down for at least 1 gram per liter, and pH rise. We also have one data from France that shows that over a 35 years time span, alcohol even increased from 11 degrees From 11% to 14, pH from 350 to 375, while the total acidity decreased from 6 to 4.5 gram per liters. Now I will explain why this is important. So alcohol levels exceeding the 14%, it negatively affects the wine balance and its quality. For this alcohol, for the wine, it is important to have the good structure, the good polyphenols, the good anthocyanins, and the good body, which can handle it. If you have the empty body of the wine, then you will not have the balanced wine for this level of alcohol. pH is one of the most important parameters when we speak about the microbial stability of the wine, when we speak also about the color stability of the wine, and also it influences the wine sensory. So higher pH usually before makes wine taste rounder, sweeter, and less sharp. You know, when the pH is low, you have higher acidity level, and acidity gives some kind of the sharp. And sometimes this higher pH consumers can perceive positively. But if we have the too much high pH, it will reduce the freshness and also can influence the stability of microorganism in the wine. It is important to bear in mind that wine is some kind of living living microorganism inside, living liquid. So it is very important to keep the control on the pH and total acidity. For example, the higher pH will favor the growth of some undesirable microorganisms, like it is Brettanomyces bruxellensis, and other microorganisms like acetic acid bacteria and so on. And the consequence of this is addition of higher preservant for the wine, which is SO2. So SO2 is usually actually potassium metabisulfite is the mainly used in the winemaking industry, and the addition of this antimicrobial thing to say is very important for the wine. But if it is added more than it is needed due to the high pH and so on, it can also influence the sensory profile on the wine. And it is known that these sulfites influence the uptake of the human. Sometimes the biogenic amines are also formed, and it can influence and form the headache when you drink too much wine, which has the higher SO2 addition. So it is known that globally alcohol content increased globally, and it is known that climate change attributed to this consequence with 50%. And what is also one consumer concern is that higher alcohol levels also conflict with health trends, which are in recent years more higher and higher. People are more aware about the influence of the alcohol uptake and so on. And when you have the higher alcohol levels, they will choose. Speaking about sensory influence, we have a decrease of fruity notes, flower notes, but also when we have higher alcohol, we can have the higher bitterness and astringency, which will make your mouth, not only burning, but also like it will not be smooth. It will be harsh. It is the best describer. It will be harsh in the mouth. Therefore, for the winemaker, what is important is to perform a stable and good controlled fermentation in the winemaking. So when we have high alcohol, it can make the stack of the fermentation. Actually, it can make the slow or even the even stop alcoholic fermentation. Also, malolactic fermentation can be slowed, inhibited. You know, as I said before, that grape juice actually, and wine is not easy medium from the grape yeast, which perform the most important process in winemaking, which is called alcoholic fermentation. So winemakers usually choose selected commercial dry yeast to perform this alcoholic fermentation. And usually these yeast are tolerant to the conditions of the grape must and grape wine. I mean the wine during alcoholic fermentation. And if we have high sugar in the must, we will have also the high osmotic stress on the yeast, and therefore we will also have the problems maybe finishing with the fermentation, because yeast convert this sugar into alcohol, and at one point we will have too high alcohol on which the yeast are usually intolerant, and they cannot handle with so much high alcohol, and we also have the stack fermentation. The high sugar content in the grape must and the alcoholic fermentation with that kind of must, it leads on also to the production of the higher glycerol content. But what we also have, glycerol is desired. It gives the viscosity to the wine, and it gives to the wine better body. But sometimes we can also risk that we cannot handle with acetic acid, which is not desirable, or other undesirable byproducts. I will speak a little bit more about the pH of the wine and why it is important to have the best pH wine in the grape. So, as I said before, climate change leads to the higher pH and lower acidity, and it influences the biological stability. So, in the beginning of the fermentation, in these early stages of fermentation, we do not have ethanol content at all, And during that time, we have some kind, if the pH is high, because microorganisms are sensitive to the acidity in the wine, the higher acidity, the pH is lower, and microorganism can perform, especially undesirable microorganism can't perform their activities. They cannot multiply. But if we have high pH, the microorganism can multiply, can use the nutrients from the grape must, and can produce undesirable flavors. For example, the Brettanomyces bruxellensis can produce volatile phenols, which are, not desirable, and other off flavors. So as I said, the lower acidity gives higher sensitivity to microbial contamination. pH also affects the color of the wine. If the pH is lower than 3, we have the shape of anthocyanins in the flavoylium cation, and we have the good red color. For the wine tasters, consumers, when you choose the wine, you also look at the color of the wine, and it is important to have the stable and the good color, which is refreshing and not, dead in some kind of way. And so the lower pH is a little bit better. But if the pH is too high, over than 3.7, these anthocyanins shift to colorless carbinol base. So less pigment, different shape of anthocyanins, we will have the weak color. And we will also have reduced pigmentation. In the wine, during the alcoholic fermentation and after, there are thousands and thousands biochemical reactions, And we have also in the wine co-pigmentation reaction of anthocyanins with flavonoids and phenolic acids, which usually gives blue and purple hue. And when we have the too much high pH, this co-pigmentation is reduced. So we have the influence with this high pH on the low color stability and the visual appeal, which is, after all, also one of the important factors that influence the choice of the wine taster, consumer, or lover. What is also important is the connection of pH with sulfur dioxide efficiency in wine. SO2 represents a key preservative, which is antimicrobial and antioxidant in the wine. And it usually, I have to explain the forms of this molecule. It usually exists in bisulfite and in small part as a molecular. And for us winemakers, the most important molecular is the molecular SO2 because it is the active one. This molecular SO2 kills undesirable yeast and microorganisms, and they are sensitive only to this molecular SO2. And when the pH increase, this fraction of molecular SO2 decrease. So we reduced antiseptic efficiency, and therefore my winemaker are, how to say, they are demanded. It's needed to add the more quantity of the SO2, which also influence, after all, the sensory profile and the human reaction of SO2 in the wine. What is also important that SO2 also acts as antioxidant, and it reacts with the polyphenols if we add it too much. And therefore, we reduce the content of polyphenols in the wines, and they are back usually to their phenol form, which we do not want. Now, if we have the combination of the elevated CO2 and temperature, how it impacts the grape composition. The first consequence, you probably know, and we are all, how to say, we are all in monitoring of the early, we all monitored the early phenology from the last year. You know that the last year we had the grape harvest started in Montenegro at least 15 days earlier than it is usual. So elevated CO2 and temperatures set earlier variation of the grapes. So we had advanced phenology, which also gives, which I said before, higher sugar content, loss of organic acidity. And what happened with the primary metabolites in the grapes? We have higher total soluble solids, but lower quantity of organic acid, especially malic acid, which is very important for the grapes. It is usually becomes rapidly degraded comparing to the tartaric acid. The secondary metabolites in grapes are anthocyanins and sugars, and this ratio also goes down. It is also known, the literature suggests that total anthocyanin concentration goes down, and this is due to the indirect effect because with more dilution, we have the larger berries, and therefore we have the total anthocyanins concentration down. And what is the CO2 specific effect also? It influences the aroma precursors, which will influence the modified aromatic profile of the wine at all. So CO2 has the minor effect of sugar acidity level, but we have favored tartaric acid over malic acid after. So what is also the effect of the actually tartaric acid in the wine? This acid is usually relatively stable until after verizon, and it is not metabolized. It is usually diluted a little bit by berry growth. But it decreases when we have the late harvest or when we have the water deficit, dehydration conditions. So we have a decrease of this important tartaric acid. Usually, beside the climate change, there are a lot of challenges with which the winemaking industry surfaces, and the one is the lack of the workers. Hard work in the field is not easy, especially due to these high temperatures. And in recent years, there is no labor, not enough workers in the field that want to work on these high temperatures. And therefore, the grapes usually stays longer on the wine than it is desired. And therefore, we have this undesirable late harvest, which we do not want because we have smaller grape berries and this dehydration that occurs. But this was about tartaric acidity. Malic acid is much more temperature sensitive comparing to the tartaric acid. It is usually degraded through respiration during the ripening. And it actually leads to the lower total content of acidity in the grapes and in the wine as well. What is also important and to say is that the heat stress influence the potassium accumulation. In the chemistry, in the grape and wine chemistry, potassium reacts with the organic acid. We obtain the salts, and it neutralizes. We have the chemical reaction of a neutralization inside of the grapes, and it neutralizes the organic acids, which raise the pH. So we have higher content of potassium in the berries, higher content of potassium in grape juice and wine as well, and we have higher pH as well. So after all, the combined effect of high temperature is lower malic acidity content, higher potassium content, higher pH, and after all, lower acidity in the wine. All of this make wine unstable, make wine flat on the flavor, not desirable to the drink, and also make problems to the winemaker due to from the microbial point of view. As I said before, wine is a living, organism, living liquid, and you have microorganisms inside which can, in some kind of way, which can wake up if the conditions are good for that, and therefore there is needed good preservation, addition of tartaric acid, addition of SO2, which is needed in higher levels due to this temperature rising and climate change as well. A little bit about UVB radiation and influence on the anthocyanins content. This is by the literature some conclusions. UVB radiation usually stimulates flavonol synthesis, especially quercetin. And during the time, while the high temperatures reduce this flavonol metabolism, it depends on intensity, duration, and also on the phenological stage when we have the high UVB radiation. What happens with flavonol profile? It shifts under increased UVB radiation, and usually mono and D-substituted flavonols increase while the tri-substituted decrease. Anthocyanins are less UVB sensitive, but heat stress reduces their synthesis and stability. The optimum synthesis temperature for the anthocyanins is 30 degrees of Celsius, and you know that we have much higher temperatures in agroecological conditions of Podgorica subregion, for example. And after all, under this heat and UVB radiation, we have poor color, because some gene expression changes. We have also the activation of some enzymes in the grape juice, and after all, anthocyanins degradation, because anthocyanins act as antioxidant and preserve the grapes. And sometimes the grape wine needs to, preserve itself by its own antioxidant inside, which are anthocyanins. High temperatures also can increase the tannin concentration in the wine, but this response varies by the vintage and by the grape variety. One compound which is important for the wine is called quercetin, and its accumulation can lead to the precipitation during the wine aging. And co-pigmentation with the anthocyanins, if we have the good level of anthocyanins, is very good, and we have the quercetin in solution at high levels. But if we do not have this co-pigmentation, quercetin along the time will, goes down as the Li. So it will lead to unstable wine over time. So after all, this can create a commercial quality problem at global winemaker, because wine will have the sediment and not will be, clear, when you buy the wine and when you choose what wine to choose, when you decide what wine to choose, you first look at the bottle, and when you have the sediment, it will probably influence the consumer choice. How much more information about how elevated CO2 impacts grape wine and wine quality. We have some potential positive effects, like we have the wine growth faster and yield a little bit higher. We have higher sugar and acidity during early ripening, better water use efficiency and photosynthetic rate. But what is not uncertain and inconsistent is the change in some compounds in the grapes and after all in the wine. It is like total phenolics. It influenced anthocyanins in red grapes, and it influenced overall the wine sensory profile. The literature, however, suggests the high variability between the studies, vintages, and also the grape varieties. How UVB radiation influence also the red and white grape varieties. When we speak about the red grape varieties, they benefit for this increased UVB radiation because we have higher synthesis of color pigments, flavonol, and tannins. It contributes to richer structure and complexity in red wine. But for the whites, it is not desirable, and this UVB radiation is much more vulnerable because it can cause some sunburn effects before verizon. Here on this picture, you can see how it looks like. And it can also lead to some kind of off flavors and atypical aging. This high UVB radiation at recent years has been steadily increasing, but the higher influence is at higher altitudes. And it has notable effects on the grape development and wine quality as well. But after all, as ozone layer changes and attitude-related exposure rise, UVB radiation becomes more critical factor in the vineyard management, and there are needed more varietal adaptation strategies to surface this challenge. And now some examples how climate change influence wine aroma. For example, some compounds which give some notes in Cabernet Sauvignon and Sauvignon Blanc as well, like methoxypyrazines and herbaceous, these vegetal notes, they drops down with the high temperatures. Sometimes severe water stress can delay grape ripening, and it can also cause elevated methoxypyrazine levels, and it leads to the green aromas and reduced wine quality. So you can see with the temperature dropping down this aroma. Another compounds, high exposure to the light and these high temperatures increases the breakdown of the precursors, carotenoids, into positive aroma compounds. And extreme heat can negatively affect their formation. For example, some compounds like beta-damascenon, it shows inconsistent behavior, and it may decrease under high heat and light. Monoterpenes, which gives fruity flower aroma in the wine, can benefit from moderate warmth, but excessive temperatures reduce their synthesis and stability. But after all, we have to bear in mind that this situation is not the same for every region, for every grape variety, and also the timing of the climatic extremes. So there is a lot of factors that should be considered in making conclusions regarding these changes of these aroma compounds. But we can say that we have influence of the temperature of the monoterpene concentration, and we can see that the high temperatures, especially the high night temperatures, will reduce these desirable compounds, aromatic compounds in the wine. What is the signature of hot vintages and high temperatures? So first of all, we have the change of aroma. Fresh fruit becomes to jammy, dried, and stewed fruit. And the typical descriptors for the wine, which are made from the grape with the high temperatures, is like the raisin, fig, blackberry jam, like cooked wines. And these typical aroma, these typical descriptors are expected to increase with these climate changes. But studies show that these overripe aromas, especially in Merlot, it will also happen with our autochthonous grape variety Vranac. It can negatively influence the consumer satisfaction and willingness to pay. From personal experience, these days I am in China as a wine judge, and I speak with the people which are in wine business, which works in the restaurants, which import and export wine, with the wine sommeliers. And the trend is the people like more the fresh fruits notes, not these jammy and dried notes. So willingness to pay for this kind of wine dropped by up to 50% with this kind of aromas. So for the winemaker, it is really important to make the balance between the ripeness and freshness. And these wines, which have overripe notes, were rated as less desirable as well. So we have here the aroma groups and their response to the water stress and which aroma it gives. For example, methoxypyrazines, they content is increased or delayed. They have actually delayed the degradation if we have water deficit. And so we will have the more compound and the more flavor of green pepper. which can also influence, which gives the vegetal nose to the wines, and if it's not ripened, it can negatively influence the sensory profile of wine at the end. Then the monoterpenes are, their synthesis is reduced, and there gives the flower aroma to the wine. Non-isoprenoids are variable and can increase or shift, and it depends on the grape variety, as I said before, the timing of the extreme weather conditions, and so on. What the grape growers and winemakers also surface due to the climate change is the stack ripening. You know, where we have really, really high temperatures, the tree, the plant cannot breathe. So the respiration rate comes higher, we have lower sugar transport, and we have signals from the hormones. So we have, after all, the disruption of the berry metabolism. And sometimes when we monitor the grape ripening and look at the sugar content every couple of days, at some point we have no increase of the sugar content. That is also the problem, and the result of this, the stack ripening. Because of that, we have also delayed or incomplete flavor aroma maturation, lower content of monoterpenes, and after all, lower fruity and floral notes in the wine. The wines which are made from this kind of grapes, after all, are not expressive, and it lost its varietal typicity. If we take the case of Sauvignon Blanc wine, if we have hot and dry years, like we have in Montenegro last years, Sauvignon Blanc is grape varieties that has typical thiols and aroma, and I don't know, I mean, it has the aroma like the grass and vegetal aroma, which cannot be obtained in the terroir with the hot nights and hot days. What also is happening, that during these high temperature conditions and dry years, the grapes of Sauvignon Blanc obtained more tannins and less glutathione. Glutathione is compound which acts also as antioxidant, and it protects aromatic freshness. So it is also one important compound which we lose due to these high temperatures during the day and the night. So this was the influence by now of the high temperatures and which is combined with other variables of the climate change on the wine quality, grape quality, and wine sensory profile. Now I will speak a little bit about the adaptive strategies. So climate change shifts wine's aromatic identity, typicity, reduce acidity, and after all, we do not have balanced freshness, fruits, and longevity of the wine. And in order to preserve aroma, freshness, and balance under these changing climate conditions, it is just a little bit about the some viticultural adaptations. So for the winemaker, the most critical moment is the date of the grape harvest. It is important for the grape grower to control the vigor of the wine and to avoid water stress if it is possible, to monitor disease during the grape growing, and which will anticipate, after all, aroma and aging potential as well. One of the very important strategies is the clonal selection of autochthonous grape varieties in order to find the grape variety that ripes later, and to check varietal diversity of the grape varieties in the country. For example, in Montenegro, it is discovered that we have a very rich genetic genetic diversity of the grape varieties, and in the future it is important to make research on them to see how do they act and how they surface with these climate changes as well. So continuous research and monitoring is also desirable, and continuous study of these multi-factors which influence the grape composition and wine as well. So adaptations to increased temperatures from the viticultural points of view. As I said, we have the imbalance in grape composition, reduced wine quality in the warm region, and very early season ripeness. So what could be adaptation option is to choose the late ripening clones or long cycle rootstocks for them. So introduced late ripening grape varieties and to test them in the vineyard, and also carefully consider some non-local or old neglected grape varieties from the country in order to preserve wine style and to find new grape varieties which are adapted to these climate conditions. Speaking about the vineyard management, higher trunks and late pruning usually delay phenology, and it is important to pay attention on low leaf area ratio to the fruit weight ratio. It delays variation, but sometimes may reduce the quality. And grape growers and the winemaking industry should consider also the higher altitudes or planting the vineyard at the higher altitudes as well. When we speak about the drought, it is important to select the good plant material and to design vineyard for the drought resistance. Rootstock selection is also the key. For example, to choose 140 Ruggeri or some other, and to choose Mediterranean grapes varieties which are tolerate to dry conditions better than Atlantic ones. Also to choose the right training systems and to pay attention that adaptation is cost effective and eco-friendly as well. Also to monitor water holding capacity of the soil, to monitor rainfalls and evapotranspiration of the vineyards of the plant, and also to choose the best soil and to select the site for the planting new vineyards. For the water stress, irrigation should be the last resort, but in our condition, without irrigation, it's not possible to grow the grapes. But because of that, we have the environmental, economic, and social cost higher. And we also have the risk of the accumulation of this water during the winter. And the deficit irrigation is recommended if it is possible. It saves water and optimizes grape quality. How to manage excess radiation? So as I said before, excess solar radiation can cause sunburn on grape berries, especially in high altitude vineyards. What are the strategies that can be included to adapt good training system and canopy management to reduce leaf removal, and use maybe some kind of UV filtering nets to shield the grapes from the harmful exposure. And for the winemaker, the first thing and the critical point in the winemaking is to choose the time when to perform the grape harvest. In past, we had usually just technological maturity, which considered the balance of sugar and acidity in the grape. But today we have more, more definitions of maturity. We have technological, physiological, phenolic, and aromatic maturity of the grapes. And these all parameters are highly sensitive to the temperature, to water availability, and sun exposure. So in this era of the climate change, achieving grape maturity that is balanced is a really new challenge also for the grape growers and the winemakers as well. So, as I said before, if we choose the early harvest, we will maintain acidity. We will have good acidity level, but we will not have enough sugar content for the desired alcohol. But what we also do not have, especially for the red wines, we will not have phenolic maturity in the red wines. And it's not easy to match this sugar content, acidity level, and phenolic maturity for the red wines. So for the winemakers, it is a challenge. Should we choose phenolic maturity or technological maturity? If we want to achieve ripe tannins and anthocyanins, we must usually accept even high alcohol and low acidity. As I said before, it can reduce anthocyanin accumulation, and it usually push us to harvest grape earlier than it is usually needed. Grape harvest under climate change, when we speak about the wines, we have the key floral compounds usually increase during the ripening, but if the grape is overripe, they decrease. Due to the high temperatures, we have earlier ripening, and therefore we have the risk to lose aroma. If we do the early harvest of red wines, we will have higher content of methoxypyrazines, which will give green vegetal aroma. But if we do it later, we will have these cooked black fruits notes, late harvest aroma. For example, in the case of Cabernet Sauvignon, early harvest will give vegetal notes, but late harvest will give this cooked fruit. So harvest timing represents the central and controlling not only for the structure, but also for the aromatic profile of the wine. Winemakers have some strategies and techniques how to reduce alcohol in the wine. As I said before, we had the main consequence is the higher alcohol content in the wine due to the higher temperatures. So these techniques are categorized in pre-fermentative techniques, fermentative, and post-fermentative techniques. Pre-fermentative techniques obtain early harvesting, about I was already speaking. Then we have must dilution, grape juice dilution, but it is mostly restricted and prohibited in many countries. It is just water addition in grape juice or wine, and it is not desirable techniques at all. We can also blend wine. We can do grape harvest early and also all the time late harvest. And after, when we obtain the wine, we can blend it and to obtain some kind of the balanced wines. There are also some techniques like anofiltration, which can separate sugars. But I have to admit that in Montenegro, we do not have experience with this and with this reverse osmosis. And there is also possibility to use enzymes that will convert glucose to gluconic acid. And it will make alcohol content lower and it will raise a little bit acidity. But the risk is that we may reduce fruity aromas. I can admit that the best fermentative strategies can be used for the adaptation, and I will speak mainly about them. So it is possible to use modified Saccharomyces cerevisiae strains, which shows reduced ethanol yield. But what is the problem? It can increase glycerol, acetaldehyde, and some negative compounds like acetoin, which can negatively impact sensory quality. And also, sorry?
There is someone with the microphone open. Sorry, Sonia.
Są dobre, co?
Adjusted.
Svolchi englezki je dobro. Pa, ajde, nagasimo ovo da kapimo tele.
GG.
Sorry?
Jedna. To je Luka što me prepada. Meni si neko.
Is it okay now? Hello? May I continue?
Sorry, I mute myself.
Okay.
Yeah.
Okay.
It's okay now. Thank you. Sorry.
Okay.
Let's continue.
Okay, thank you. Thank you for patience. I do not have so much, so I will finish soon. So thank you for the patience. What is another concern about this modified Saccharomyces strains that consumers are concerned, and there are some limited regulations in the use of GMOs in winemaking. The best thing is to use non-Saccharomyces yeast. So usually the strategy is to co-inoculate them with Saccharomyces cerevisiae to steer metabolism away from the ethanol. What is actually the aim? To retain quality while reducing alcohol content in the wine. So these are some non-Saccharomyces strains that can be used, like Mechnikova pulcherrima. It has the low fermentative power, promotes varietal aroma via enzymatic activity, and it usually reduces ethanol content up to 1.6%. It also improves aroma. There is also Torulaspora delbruetzki. It produces low acetic acid and releases polysaccharides, which gives the better mouthfeel to the wine. The most important is that it enhances some good aroma compounds and reduce ethanol content for 0.5. And there is one more, Stermerella bacillaris, which is fructophilic. You know, when during the grape ripening, in the optimal time for the grape harvest, we have equal level of fructose and glucose. And the yeast usually firstly ferment glucose, then fructose. And sometimes if the grape is overripe, we have higher content of the fructose as sugar. And it is important in that case to have the yeast that will like this fructose. So Stermerella is fructophilic and it's tolerant to high sugar and low temperatures. Increase also glycerol and acidity and good aroma compounds, survives till fermentation and ensures stable mixed fermentation. Just to say about the post-fermentative techniques, me as a winemaker, the point is that it's about some kind of dealcoholization and so on. I have to admit that in Montenegro, regarding technology, we are away from that, and I guess that I'm speaking for the all winemakers point of view. Winemaking process is natural process, and the main product of the alcoholic fermentation is ethanol, alcohol, and some minor compounds which influence the wine quality and sensory. And the point of the post-fermentative techniques is like using some techniques to make the alcohol lower. And to my opinion, there is no point to do this, especially to make the alcoholized wines and so on. So I in this presentation, I wanted to talk only about what we can do before alcoholic fermentation ends. And that was it. And here is some references that I used for this research. And thank you for attention and patience. And if there are some questions, I am here to answer. Thank you very much.
Daniel? Is there any question regarding this presentation?
Okay, thank you, Sonia. At the end, we will hear closing words of the summer school from Professor Marko Simonovic.
Okay, thank you.
Thank you.
I have 13 minutes, I believe. I'm just kidding. I will be as short as possible. I would like to thank all participants to take a part in this summer school. And I believe for our students that we somehow show that the problem of climate change and viticulture is a very large, and that for different type of expertise, that each expertise can find their something to work on this. And I believe that in the future, some problems that are presented here during these 3 days can be the subject of the research in your future master or PhD thesis. I would like also to thank our presenters here. Special thanks to Christoph and Natalia for great help, and for that they were here all 3 days and helping in the realization of this summer school. So I hope that the next year we will continue with some other summer school, but probably with more coffee breaks than that was here. The guilty for only one coffee break is Natasha, so it's not I. Thank you once more.